Okay. You're live. Hello. I figured I'd do a little bit of a stream today. I think we're going to. We're probably gonna mess around with Tinygrad for a bit, and and then watch the Ilya podcast finally, because that's about what I got the energy to do. Still have not fixed the vectorization bug. That will come with time. Hey Pepe, hey Kinvert. Let's start with Tinygrad though. And then you can expect the streams to slow down a bit, I'd say, next week. I don't know. I'm kind of at a point where it's close to the holidays. I've been working on this update for a couple months straight, and I sort of just want all obligations to just disappear for a few days to a week to two. So I will get some rest. Holy. Just have a flock of several thousand birds overhead. Hmm. Honestly, they remind me of like the stuff we see out of our drone sims. Perfect coordination. It's fun. Let's go. And that is how you know for sure I need a break. See birds, think about Sims. Alright. What we're gonna do. Yeah, so we got this, right? Okay, so this was the Tinygrad scan op. And I was linked on the Tinygrad Discord. Oop. This. Okay, this is other stuff. Somebody linked to me. Here it is. Variable to write a kernel. Let's see. Line 210 is opened in full screen on my vert monitor. Okay, so what is this? 4JIT token variable self.forwardJIT. Tiny JIT of self.forward. Okay, so you can add variable start pause. Huh. This is kind of funky, right? Welcome, everybody. And, oh, it's by name. Start pause 1. Tinygrad variable. Where's this imported? tinygrad import tensor variable. uop.variable, so tinygrad uops ops variable. It's a big file. Def variable min val max val key type. That doesn't make sense to me. That makes sense to anybody. So start pause 1 max context -1. Wait, start pause is an int. Oh. So welcome, Liberty. Test tinygrad scan. Okay, so you need the it's a little awkward though, isn't it? Like variable this is not exactly what we want. Here is an example. Check out test symbolic JIT for a few examples with variable. Variable I test add That's so weird though. Wait, variable I dot bind So what we're trying to do, right, is just get this thing to output kernels that work with variable hidden dem. Variable hidden dem. Dot bind of I. Exported function has an extra argument for each variable. That's not bad. Let me try something. So batch size, we can do H, hidden, horizon, right? We can do like this. Cumulative sum. This still is not what I want. So awkward, like, this is such a weird way to output kernels. I mean, I guess. So it's like what? Star for all. Star, horizon. Like this? Log. Can I just do this? Tiny jet, and you call it BI. Dot bind I. Okay. Am I just stupid here, or is this not weird, right? Like, this is not the way I would expect to bind, like, to produce a variable kernel at all. How would I expect to do it? I'd expect to just, like, I don't know, specify the dimension. Like, tag the input variable dimension or something. I guess this is supposed to be more general, because it's, like, it's over whatever variable. Very odd. Eval failed to be a single number. Okay. Oh, well, hang on. I did something stupid there. Then do you pass the... Hang on. Do you pass vi symbolic to a simpler function? Oh, you do use it as an index. You do use it as an index. So hang on. So this is going to be... Cell failed to be a single number. Lovely. That's right. Okay, eval failed to be a single number. So it is actually pretty much what I said I would expect. It's not quite the syntax I would want, maybe, but it's actually... The more I look at it, the more this does make sense. So you're just going to replace index variables with this. Now, I don't like the fact that you have to, like, slice with it. This is super weird to me. Like, yeah, I don't understand how this makes any sense, but just let's try it. Because I think Tiny doesn't break debug, right? Horizon. Log coefs. Yeah, that lets you index, right? So this gives us... Okay, look, define var, hidden 128, and then it has right there the constant arg. Okay, this actually makes sense to me, right? This makes sense. Log h dot x. Train step. Okay, let's see. What does this have to get passed to the JIT? Hang on. JF is JITted function. Oh, I think you have to pass... I think you do it this way, right? You don't actually pass horizon and hidden as args. Yeah. This is better, actually. So we just do OF slice. Slice. Wait, this whole thing is getting jitted, right? Yeah, so if this whole thing is getting jitted, then we do it outside of train step. So we do like this then, right? All right, so then look at this. This slicing, it technically doesn't do anything, but I think that this tells TinyGrad that these axes need to be generic in the kernel. Takes two values before we're given. Okay, yeah, we don't need this. Eval failed to be a single number. Sum of 1. Yeah, that's really obnoxious right there. That's really obnoxious. Some of their error messages definitely use some improving. Yeah, so eval failed to be log coef. So you see here, Yeah, so now we have the actual shape. I just typed in shape and this looks like a mess, but it's because it's like a variable shape. Um eval failed to be a single number. Any tiny grad people in the chat see anything wrong? Let's I'll tweet this. Maybe we will pull some of the tiny grad people. Try that. I wonder if there is just something screwy with the cumulative sum. Let me make sure that this looks correct first. So they jit the function, and then they pass a slice through the jitted function, right? Yeah. Tiny jit f contiguous dot realize. Without contiguous, the pad is not captured in jit. Without contiguous, the pad is not captured. Contiguous? I doubt it's this, right? Eval, yeah, Nook. It's the same thing. So then why can't we do this is my question. Eval failed to be a single number. Range is false to true in this mess. Self.shape not equal new shape. Split alu. Well, that seems bad. Hey, Fabian. Welcome. I could try this on a different op for now, right? It's possible that this is just screwy for this. I have a sense of how this works. Now, let's go try RMS form real quick. Because, I mean, this is the one that we would really want a kernel from it for anyways, right? Like, this is the op that's so obnoxious. Let's see if this does anything. So we can just do... variable scan. Like so. And this just needs hidden size, right? Oh. Train step, tiny model obs. So can I just do obs like... No, this whole thing gets jitted. Hang on. So it's obs action. So this is... Like this, right? What? Uh, really? Well, that is shit. Huh. Is this a fair op to use in testing? I think it is, right? Well, if the kernel's that slow, that doesn't help me. Try the forward pass, maybe. Well, you jit the entire train loop, right? How would you jit? Wait, how would you even get yourself a backward and forward kernel? How would that work? Right, because let me, like, the thing I'm trying to do with this is if I can get tinygrad to generate me fused kernels, right, for specific operations or sets of operations, then I can essentially replace the PyTorch backend for those groups of operations with a single kernel call. Because I can just grab the CUDA and I can load it into the Puffer C++. What is Pufferlib? Pufferlib is the fastest reinforcement learning library. We got a ton of demos here, and I stream all of the dev. Everything from fun little games to drones to driving. We got lots of stuff. And not necessarily here. To be determined. I actually have not seen any of his content. It's like not the type of stuff I like. I normally don't watch tech podcast type content. If you talk about neural MMO, you should mention develop new strategies. Oh yeah, that's par for the course in RL. Are you game dev? I am a researcher, my guy. I build Pufferlib. I do high performance simulation. I do core reinforcement learning algorithm research. Do hyperparam optim. We do custom simulation. Like, we do a ton of stuff here. All open source. Um, Do you need to do 2 separate kernels? Forward. So if I do like RMS forward, right? That's cool. Thank you. Yeah, it's kind of a unique thing, if you will. I finished my PhD a little under 2 years ago now, and I sort of just took all the research that I worked on in an academic setting and then went way heavier into engineering here on the open source stuff. And we now have, like, you can literally train agents to play several of these games or sims or fly drones or whatever on your laptop in under a minute. It's pretty crazy how fast stuff is now. Like, most of the simpler tasks on here, you can train these at home in under a minute. And that was just not remotely a thing that existed 2 years ago. Give me another couple years, and then, maybe some of the more complex ones will be similarly solvable at home. Oh yeah, I'll show the... Maybe you can see this on the stream. I just got a fun delivery. Let me see if I can just... Can I spin the camera? Yeah, I can. Oh, my mic's in the way. Can you guys kind of see it? Yeah. You see that? Not break my setup in the process of showing that. We got a nice screen for here, and it's going to have all the experiments live on it for the foreseeable future. That's about where it was, right? No. But currently I have Neural MMO runs up on it. Saw the gym pumps. Gym pumps. I mean, we got a lot of stuff in here. I just did first bench set before stream started. Other ones shortly. What UI you're gonna put on it? We're gonna try Wannabe again. And if that sucks, then I think we'll just run Constellation on it. Constellation's the new one that I've been working on for Puffer 4. But like, Constellation really is not designed at the moment for real-time experiment monitoring. And I like something that I can kind of just watch over time. You know? Twitter broadcasts are broken again? Seriously? It shows me as live. So it looks good from my end. No, it has me live. Bit slow. That's on them. I can't do anything about that. I have my usual setup here. I'm trying to think what you would do for backward here, right? It's a little scuffed. Okay, so we're gonna do here. We're gonna save all this. Hang on. There are a couple different things. Let's not get overzealous here, right? So first of all, we're gonna make sure we have this. Okay. So now this one. Welcome, Peru. I got stuck on the multi-threading implementation. There's one last bug I can't figure out how to fix. It's actually kind of more complicated than I expected it would be. Maybe I should show you real quick. Here. So Peru wrote the original version, and then I did a whole bunch of stuff from there, but second. Making progress on native eval that will work better. Are you sure? Let me see. Wait. Puffer native. Is this still using torch? It is. Okay. Ignore the lib torch. Okay. Down to 4. 7. Let me see. Thread work. This is super C++. What is this? Wait for signal to do work. Add work. Wait all done instead of. Can't say I'm a fan of all the C++. Complicated atomic index. C wait. Hang on. Yeah, this is missing the key thing that was making this complicated though, Peru. So like, let me show you what I was working on. Because like the key thing that was making this hard was not the atomic like there's this whole additional thing I had to add because of the GPU synchronization. Like this is the entire C thread step function. It's not a lot, right? The thing that makes this difficult is you actually have this additional layer where you're synchronizing the GPU. So you have to wait for when the actions that are on the GPU buffer are ready because they've been transferred to CPU. Then you have to add work. And then you also have to then wait until... So this is actually the step that I can't figure out how to do well, which is just figuring out when they've completed a block of work, rather like... Because they can do blocks out of order, so it needs to be completed the next block of work. But then after that, you have to initiate mem copies. For testing, these are synchronous, but these are going to be asynchronous. And you basically need to say, hey, the observations are ready on CPU here, and then the main thread has to check when the obs that are on CPU are done being transferred to GPU. So, like, there are multiple layers to this thing, And pretty much the key performance improvement that is expected here is going to come from buffering the GPU transfers. Coincidentally. I mean, this is in 4.0, I'm pretty sure. The thing is, I cannot figure out what I've done wrong here, that this can be done out of order or something. I have a test that says, you know, if I run this twice, do I have the exact same obs and stuff at every step? And I cannot get that test to pass. So I don't know what's wrong. I'm sure there's like some pretty basic error in here, and it's just kind of getting to that time where I need a few days off before my head's going to be clear enough to do something this complex. Because like there's a lot going on in here. But yeah. I also don't love that we still have some form of busy waiting on this, right? Like this thread is constantly going. So this ideally should not have to busy wait or like to just busy loop, whatever. I think this is the only spot where I have it at the moment, which is okay. Pretty new to RL. Do you think I should jump into a project, take a full course? My guide on X, man. All my best advice is here, because this is the question I get most often. This article. None of the RL courses I've seen are any good. So there's some material, some formal material, but it ain't a course. No busy waiting, and it's lock-based. Right, but like, the reason I have busy waiting is not because of your original design. The reason I have busy waiting is because of the additional GPU synchronization. You see? Like, this entire thing is looping constantly. So this thread needs to be designed better, I'd say. Oh, the other thing that drives me nuts here, so I couldn't figure out how to do this. You have all the threads, like, grabbing work. I need to know when a block of work is completed, which means I need to know, what is the minimum index any thread is processing at any given time. Use the old C code with the new libtorch stuff. Libtorch should not be part of this in any way, though, man. Like, libtorch should not have anything to do with this. Why? Like, if this is correctly designed, this should be completely separate from it. Different segments in a BPT run proceed on their own. No. Constant for the entire... Can the different segments... let me think. That wouldn't make sense because you need to process... You need all the elements in a batch before you send it to a network. You could technically do them out of order, and we used to do that. I don't think it's a good idea, though. libtorch to transfer CUDA. Simpler design. It doesn't, though, Peru. Let me show you. You don't need to involve libtorch at all. Here, check this out. These are raw CUDA Alex. So this is, this here is in pinned memory. And then here you have the GPU buffers, so there's no dependence on torch whatsoever. Look, no torch here at all. And then this is how I did it. Oops. Check this out. Boom. This is, you just tell torch to use the memory that you allocated from the ends. So this is actually completely framework independent. Like, I could use this exact same rec with TinyGrad or Jax or whatever I want. And there's zero perf cost to doing this as well, because you're just sharing memory addresses. Like, honestly, the only thing, like, other than the design quirks, the thing that's driving me crazy is just that I cannot figure out how to make these tests work. So how to make, like, there's some async thing happening in here that I don't understand. Where is it? Yeah, there's some async thing happening in here that I don't understand, that something is out of order. And then the other thing I don't love is that you have to have a separate completion index per thread, which means that your main thread has to loop over all the atomics, one atomic per thread, to check if it's done. How do you run forward LSTM pass, by the way? Final copy stuff from after torch runs. So here, I'll show you the Pufferlib extensions. I'll show you it's completely separate. Okay, so in compiled evaluate, this is the forward function. So, hang on. Yeah, vec receive. So this thing is going to populate this buffer. And then you grab your batch from here. The policy runs on this batch. You compute actions and you fill up your buffers right here. Then this is here. This is copying CPU. This is copying GPU actions to the GPU buffer. And then vec send is going to async put these actions back to CPU and tell the environments to step. So you can see, like, there is no interaction whatsoever between the policy and the env directly like that. It's just this receive and this send. That's it. And then, like, this device synchronizer is going to go away. All of these, like, synchronous transfers are going to go away, and everything gets to be async. But essentially, I have spent a couple days fiddling with this, and this is confusing to me, and this kind of requires me to be on point to figure out. Running torch for forward? Yes, exactly. You don't have to use CUDA direct for memcopy, though. You can use torch's indexing, actually. Funny enough. Because the thing about this... Okay. Here, hang on. So, where's this? I think that the way I have this at the moment... Yeah, so this is going to end up being a synchronous GPU transfer. And then when you call send, this will initiate a... I guess it will end up being a memcopy, right? Yeah, it is a CUDA memcopy. This will end up being a asynchronous GPU to CPU transfer of actions. And then there's an internal mechanism that will check. It just, like, waits on the CUDA stream for this operation. And then when this is done, then it'll actually step the M's, and that all gets to be async. Is this up to date? Let me push this for you so you can see it. Actually, yeah, let me push you these couple tests so you can go look at it if you want. Because I can't figure it out, and if you can figure it out, that'd be a great help. So there's this DLL test, and you basically just scripts you build the vec, and then you build DLL test, and then you can run test DLL like this, and then you'll get a mismatch eventually. That's the annoying bit with it. Well, I think that this is going to be moot anyways, this test here, if the speed is not up to par. So, like... See if anybody replies over that. Interesting. Yeah, because, like, the thing is, without this... I'd really like to get kernels into this. They have to be variable? They don't have to be variable kernels, I guess. That is substantially less flexible, though. I'm trying to think if we could do forward. Really not a nice, clean way to integrate that at all, is there? So basically what I was going to do is I was going to figure out if I could get tinygrad to, like, let's say we have a few gate operations, right? Each one of those is going to launch its own kernel. It's really annoying. So we were going to have tinygrad fuse some of those, which would reduce a lot of the overhead associated with that. But, like, first of all, tinygrad is generating fixed size kernels. So, like, I'd have to pre-compile, I guess, every kernel size and have a way to load them. And it's just tough because all the stuff I'm trying to do, it's like, basically, nobody has docs for the stuff I want to do, including Torch. Oh. There's more stuff to work on. Let's take a quick look at Vec anyways. I don't know. I feel like I can take a quick look at Vec. And then, what, it's 3? So if I start the podcast within the next half hour, I'll have time to finish it before dinner. So that's what we'll do after, is we'll watch the Ilya podcast. See how that goes. Let's do Pufferlib. Yeah, and I like to be fair, I've never actually heard Gorkesh's interview style. So basically, all of my opinions from it come from interacting with viewers of the podcast coming and saying dumb shit on my stream. But that could very well just be because he's got like a broad general audience, right? I don't actually know how he does in the interviews themselves. Ugh. Give me a second. Let me go wipe my nose and then let me get a bench set in. We'll take a quick look at compile at multi-thread and then we'll go from there. Well, that is a tied PR set. 15 pounds lighter than the last time I did that. 210 for 10. All right, let's go. Hey, Hyper. Whew. All right, so let me show what was going on here. Basically, I've got this script that builds this end binding file. And then I've got also this script that builds a test. And the test says just make two environments that are both multi-threaded and see if they do the same thing. Hang on. I thought of one thing. Okay, and good. So there's nothing random in the environment. I did remember to comment out the RNG. So because there is no randomness in the environment, this test should give us identical results. And that time it did, but there you go. So it can mismatch, right? So something is wrong. Mismatch at index 256. So the design of this thing, you have this manager thread You have a number of buffers as well. Number of buffers is different from the number of threads. So you go through all the buffers, and this says if actions are ready on the GPU, this is a flag that gets set as soon as you start transferring actions, and this is the GPU stream that it's being transferred on, is synced. So if it's ready on the GPU and synchronization is done, then we add this block size to the end index. We wake up the workers, and we store here. Right? Yes. And then to check if they're done, we go through the completion indices for every thread, and we make sure that no thread is working on a piece of data that we still need. So basically, the minimum index has to be start index plus block size. That's what it's got to be. If any thread is working on something that is earlier than this index, it's not done yet. This says we can mark obs ready on CPU, which we do here. Technically, they're already ready on GPU as well. That is fine. Hello, Jess. We looked at one quick thing with TinyGrad and got stuck, and now I'm looking at Vec. And then probably in about 20 minutes, I'm going to go watch the Ilya podcast on stream. Since I said I would, and I'm tired, and I've been putting it off, and it's a good thing to do. Like, it's a good thing to do when I don't have too much left in the tank. Which I've been saying for a week now, and I'm going to keep saying it until I take a week off. Probably next week. Yeah, it is. It's kind of annoying as well because, like, when I get burnt out, I don't even have anything that I want to go do, right? It's not like, oh, I want to take some time off to go do this or that. Like, I literally don't even have anything else that I want to do, but I can't really do this. Like, this is literally, if I were active and, had the energy, this would be the most interesting thing I could be doing. But, what are you gonna do? Maybe I'll go do a bunch of flexibility training or something. See if I can make some advancements on. I've been working on that for the past couple of months. I figure it'll pay dividends. Okay, what the heck did I just do wrong in this? You say thread wake up, walk around nature rather than run around it. I could, to be fair. I could totally just do that. No, probably if I just forced myself to, like, screw it, I'm gonna go for a 4-hour walk. That would probably help a bunch. Completed, and I think this is fine, right? We say, hey, threads, wake up. While the completed index, which is the completed index of this thread, is less than the end. You load the index, right? This is the last index that's completed. And if you load this index, it means you don't have any work left that you're doing. So this is how far you've completed. Yeah, I hear you, Jess. Well, completed is less than end. You get the work index, and you add the block size. Block start. Wait, block start. Huh? Atomic fetch add. Yeah, okay, so you grab the work index, and then you add the block size. So this is before you add it. If it's greater than or equal to the end, then we have overcounted, so we undo this operation. Oh, hang on. What happens if you fetch a block of work here, right? And then the end gets incremented, so the other threads wake up, and they start completing work. They would start completing work that is too far ahead, right? But then what happens? I'm trying to think if it's possible that, like, with some weird async stuff, this allows you to skip work. Nuke heavy ball because it wants to compile. Yeah, we are going to do that, man. I told you, I re-implemented the heavy ball muon. And it works. Like, it works really well. We already have it running neural MMO. Neural MMO is... Nah, it's only at like 4.5 perf on the new run, though. The new run I was testing with, I was testing different gamma and lambdas. It did something really weird, though. This is double buffering? Yes. This is double buffered. Hang on, let me see. So if we do, maybe I'll try to draw it. Okay, so... let's do, like, end equals 48, work equals... So this is done here, right? So, like, let's say we're done with block 1, and then this is going to be T0. So in thread 0, we get the block start. So block start is going to be 2048. Then you do plus 56. And then some other dude wakes up. and does, wait, let's see, the completed index. Say we have completed this 2038. Then some other dude is going to come in and take this block. I'm trying to think if you can get something like this happening. I think you can. Completed index. So completed index less than end. Multi-threading is actually very, very complicated to think about. Like, it's actually kind of funny how I was like, it's like 30 lines of code. But this is actually very, very difficult for me to think about. Like, I'm used to thinking about parallel stuff all the time, but like concurrent stuff like this is actually very difficult for me to, like, actually kind of breaks my brain. Because, like, the thing is, you're used to code being executed in order except where specified otherwise, and then this flips it where everything is out of order except at specific synchronization points. And yeah, sure, technically CUDA is like that as well, but not for practical purposes. Like, you don't end up with the same type of race conditions in that versus in this at all. Not often. I think as soon as you count past the end, you're screwed, right? Because somebody else goes and grabs that block of work. I'd like to just have a simpler count, like a simpler model. There's got to be a simpler way to do this, no? Ultimately, all I'm trying to do is tell when a block of work is completed. Let me try with like a very specific. Let me just see if there is an existing thing. This model sucks though, but we'll try it. Oh, geez. Java 7 Plus. Lovely. Barrier per block. The most dogshit code you've ever seen. Per block counters. So, I mean, every single one of these... A barrier... Wait, is it barrier... Wait, did this barrier per block counter? What the hell is this? For each block... Falling out. Oh yeah, this Grok is a stupid model. I don't know what the hell they did to it, but it's literally worse than whatever they had before. It's like faster time to token, but the model's just stupid. Do you think Pufferlib could still significantly speed up RL workflows if my environment requires solving a linear system of equations at each step taking around 0.5 seconds? No. Why are you doing that? No, you do not do RL at 0.5 steps per second. There are no libraries that will help you with that. That is simply just not a fun place to be in. If it's not, if there's any way to cache stuff or something and speed that up, like do that first, because otherwise it's just intractable. Golang does it. All right, Jess, if you know Go, like, how would you do this? This should be a very standard problem, right? Simplest way possible to just like, I mean, literally, it is just you have a bunch of tasks and you need to know when like a specific block of them are completed. 10 to 100 SPS. Many asynchronous environments as possible. Get around 10 to 100 SPS. Can you cache stuff? Ten to 100 is still no good. Like, do you really have to solve a different system of linear equations? Latch count. Okay, hang on. What's this? Latch countdown. Oh. Wait, does that make sense? You guys, that's super easy, isn't it? Like, I don't have it designed exactly for this, but... Caching is not easy. You need to run an electrical simulation each step. Simulation. Are you only changing the simulation a little bit? Do you need to full solve it, or can you do like... Pretty much the key to like applying RL to just about everything is just figuring out how to do a fast approximate sim. This is a pretty good pattern though, right? Like, this type of a thing. And this is actually quite easy, because it's literally just a modulo to know which block this is in. Oh, and I'm pretty sure we're guaranteed that you can never... It's a circular buffer, but we're guaranteed you can never eat the tail of the buffer. I think this works. I don't have time to implement this now. Because this is going to be C, obviously, and I have to restructure a couple things. But I think this is a way better way to solve it. And this is actually way quicker to check. So this will be fast as well. Oops. What the heck? Huh? What did I just do? I didn't even know you could do that. All right, I think we're gonna do the Ilya podcast next. I'm happy with that bit of progress. I will definitely be able to implement that. Training the parameters of a circuit and rerun the simulation for new params. Thought about training like a circuit model and then jacks everything. I don't suggest trying to replace your circuit with like a learned sim. That I definitely don't suggest. Is RL and LLMs and RL in like robotic sim the same principle? Nope, not remotely close. RL and LLMs is like stupid baby mode. And the fact that you see like results competitive with RL from really dumb methods is because they're using the dumbest possible version of RL. To be fair, some of the robotic stuff is a bit bloated, but at least you can learn proper value functions and such. Robotics also suffers from just sims being slow. Let me go find that podcast. Bye. How should I put the cameras for this? Let's do like this. Reaction content. Look, people asked for it, okay? Let me resize. I'm gonna make the chat a little smaller for this. Get a fake mustache and make this take 10 hours. Alright. Let me get my bench set in. I'm a chat. Hey, he actually has some decent stuff, alright? Like, of the actual tech streamers, he actually has some decent stuff, alright? Yeah, let me go get my set in. I'm gonna use the restroom real quick. We'll watch this, and that'll be today. And eventually we'll get some real work. Eventually. Okay. Puffergen as a collab? I'd actually be down for that, honestly. Like, believe it or not, I found some of his content before I got on this crazy low-level engineering kick, and I actually got some useful information from his stuff that helped me when I was learning some more things. Batching approach. Is that Peru? Yo, Peru. I'm pretty sure we just figured it out. I think it's gonna be this. I don't know why I didn't think of this before, but I think of this, it's this type of a thing where we have one counter per buffer, and it just counts down. I think this works. When the batch completes, add work to process it in another thread. Okay, we'll take a look at that. I'm going to do this thing now, though. So let me... I'm not going to answer random questions during this that aren't about this thing. I'll probably upload this to YouTube as well. So let me give you some context for this, okay? Context bit number 1. This is not the type of content I normally watch. I don't usually watch, like, ideas in AI. Heck, I don't even watch, like, AI stuff in Hollywood or anything. Obviously, this isn't that, but I'm not really a fan of, like, you know, big thoughts in the field or whatever. I really prefer, like, detailed technical content on precisely, like, this is what we're doing in research. Clearly, this is what's going to work next. We know this from X, Y, and Z, right? Much more precise things rather than big picture. Everybody's wrong half the time, but, like, maybe this guy's wrong a little less than half the time, right? So that's context number 1. Context number 2, I did spend some time at OpenAI. I interned there for about 6 months as an undergrad at Stanford. And then after that, I followed Philip, who I worked with there, to MIT because he started a professorship and he became my advisor there. I knew Ilya from there mostly via conversations I had over lunch. He is one of the top 3 probably smartest people I've met. He has, I mean, just the amount of stuff that he's done and the way that he saw the field at that time. Also, you know, having been at those places, I can say that OpenAI in 2018, like, you go from there to MIT or Stanford, and it literally looks like Dumb and Dumber. The people that were at OpenAI just blew everybody else out of the water. It wasn't even close. So, yeah, that's pretty much it. Is I know him from having, you know, he led the technical team that blew everybody else out of the water in the era that produced what is, in my opinion, the greatest RL results ever. In addition to, obviously, GPT, the stuff that Alec was working on there. Tons and tons of stuff. So I have a ton of respect for Ilya. People, like, comment weird stuff at me about effigies and shit. I don't know what the fuck any of that is. So I'm going to go just off of this. I'm going to see if Ilya's the same as I remember or whatnot. I've never heard Warcash talk. The only negative impressions I have of him are from viewers coming and commenting stupid shit about, you know, the latest podcast episode in my stream. But that could very well be because it's just a very general audience. I don't know. We're gonna see. And I'll tell you what I think about it. Not sci-fi enough yet, man. Because you haven't made any sci-fi yet. We can hear you, but not Ilya. I am dumb. Let me fix that. Alright. Here. The initial... Alright.
You know,
So, the reason that AI doesn't feel sci-fi is nobody's done any cool sci-fi shit yet. Like...
it's crazy.
Let me know when it produces
But all
magic.
of this is real.
Alright, here we go.
Don't you think so?
Meaning what?
Like all this AI stuff and all
Like
this
it actually
Bay
happened?
Area, yeah, that it's happened. Like, isn't it straight out of science fiction?
Yeah. Another thing that's crazy is like how normal the slow takeoff feels. The idea that we'd be investing 1% of GDP in AI, like I feel like it would
It's
have
not
felt
cool
like a
enough
bigger
yet.
deal, you know? Where right now it just feels like
And you get used to things pretty fast, turns out, yeah. But also it's kind of like it's abstract, like, what does it mean? What it means is that you see it in the news,
yeah,
that such and such company announced such and such dollar amount.
right,
That's all you see.
right.
It's not really felt in any other way so far.
Yeah. Should we actually begin here? I
Is
think
this
this is an
better?
interesting discussion.
Sure.
I think your point about, well, from the average person's point of view, nothing is that different will continue being true even into the singularity.
No, I don't think
No,
so.
that's dumb.
Okay, interesting.
So the thing which I was referring to, not feeling different,
Not really better yet? Like this way the hell down.
is okay. So such and such company announced some
That better?
difficult to comprehend dollar amount of investment.
Right.
I don't think anyone knows what to do with that.
Yeah.
But I think that the impact of AI is going to be felt. AI
Yeah.
is going to be diffused through the economy. There are very strong economic forces for this. And I think the impact is going to be felt very strongly.
When do you expect that impact? I think the models seem smarter than their economic impact would imply.
No, the models are dumb as
Yeah.
fuck.
This is one of the very confusing things about the models right now. How to reconcile the fact that they are doing so well on evals.
Yeah, they're
And you look at
overtuned.
the evals and you go, those are pretty hard evals.
Right.
Yeah.
They're doing so well. But the economic impact seems to be dramatically behind.
Yes.
And it
That's just like the benchmaxing meme, right? It's like you go see all model solves IMO, whatever, and then you give it some basic ass programming problem and it completely flops. Like when you have that much money in place, there's a huge amount of incentive to do well on those evals and not that much incentive to actually make sure it's generally good. Because like at least the thing in the news and the thing with investments and all this is evals. Like you'll believe it when the models are actually useful broadly and are not constantly being stupid.
it's almost like it's very difficult to make sense of how can the model on the one hand do
Yep,
these amazing
that
things
thing
and then on the
wouldn't-
other hand like repeat itself twice in some situation in
Mhm.
kind of an example would be, let's say you use vibe coding to do something and you go to some place and then you get a bug and then you tell the model, can you please fix the bug?
Mhm.
And the model says, oh my god, you're so right, I have a bug, let me go fix that. And it introduces a second bug. And then you tell it, you have this second bug.
Right.
And it tells you, oh my god, how could I have done it, you're so right again. And brings back the first bug.
Yeah.
And you can alternate between those.
Yeah.
And it's like, how is that possible?
Yeah.
It's like, I'm not sure. But it does.
Because Hyper, I want to listen to Ilya. This is the only person, the only guest he could have possibly gotten that would have gotten me to watch this.
Suggest that something strange
Maybe
is going on.
Brockman, but probably
I have
not.
two possible explanations. So here, this is the more kind of
Maybe Radford.
whimsical explanation,
Mhm.
is that maybe RL training makes the models a little bit too single-minded and narrowly focused, a little bit too, I don't know, unaware, even though it also makes them aware.
Base models were also shit.
And because of this, they can't do basic things. But there is another explanation, which is back when people were doing pre-training, the question of what data to train on was answered. because that answer was everything.
Everything, yeah.
When you do pre-training, you need all the data.
What about Altman?
So
Fuck
you
no.
don't have to think it's going to be this data or that data.
Yeah.
But when people do RL training, they do need to think. They say, okay, we want to have this kind of RL training for this thing and that kind of RL training for that thing. And from what I hear, all the companies have teams that just produce new RL environments and just add it to the training mix. And then
Well,
the
we
question
do
is,
a
well,
little
what are
different.
those? There are so many degrees of freedom. There is such a huge variety of RL environments you could produce. And one thing you could do, and I think that's something that is done inadvertently, is that people take inspiration from the evals. You say, hey,
Yup.
I would love our model to do
It's
really well when we
benchmarks.
release it. I
Mhm.
want the evals to look great. What would be
That's the
RL
only bench I
training that would
max.
help on this task, right? I think that is something that happens, and I think it could explain a lot of what's going on. If you combine this with generalization of the models actually being inadequate, that has the potential to explain a lot of what we are seeing, this disconnect between eval performance and actual real world performance, which is something that we don't
Hmm?
today exactly even understand what
This is why I
what we
ignore all
mean
the
by
new
that.
model releases.
I like this idea that the real reward hacking is the human researchers who are
Yeah,
too focused
totally
on
what
the
it is.
evals. I think there's two ways
Dude,
to.
this is nothing new. We've seen this in RL for a decade. Like, this is why I say all the RL research is shit. Like, you literally just go look at the posters, you see the experiments that they make, you say, well, that can't possibly be generalizable. You try it, it isn't. Woe and behold. It's just like, congratulations, we managed to replicate the past decade of bullshit research, but now at the scale of billions of dollars.
Understand or to try to think about what you have just pointed out. One is, look, if it's the case that simply by becoming superhuman at a coding competition, a model will not automatically become more tasteful and exercise better judgment.
Okay, taste is such a fucking stupid concept, man. The models are just bad. Like, unequivocally bad. It's like, oh, there's like this learned subjective thing. Yeah, sure, within certain bounds. That's not what the models are. They're just bad.
Judgment about how to improve your code base. Well, then you should expand the suite of environments such that you're not just testing it on having the best performance in a coding competition. It should also be able to make the best kind of application for X thing or Y thing or Z thing. And another, maybe this is what you're hinting at, is to say, why should it be the case in the first place that becoming superhuman at coding competitions doesn't make you a more tasteful programmer more generally? Maybe the thing to do is not to keep stacking up the amount of environments and the diversity of environments to figure out an approach which lets you learn from one environment and improve your performance on something else.
So I have
You
an
do need more
analogy, a human
environments.
analogy, which might be helpful. So even the case, let's take the case of competitive programming since you mentioned that. And suppose you have two students. One of them decided they want to be the best competitive programmer, so they will practice
This is the lead
10,000
coder.
hours for that domain. They will solve all the problems, memorize all the proof techniques, and be very, very, you know, be very skilled at quickly and correctly implementing all the algorithms. And by doing so, they became the best, one of the best. Student number two thought, oh, competitive programming is cool. Maybe they practiced for 100 hours, much, much less, and they also did really well. Which one do you think is going to do better in their career later on?
The second.
Right? And I think that's basically what's going on. The models are much more like the first student, but even more, because then we say, okay.
Is that what it is? I guess in my mind, like, because I'm so used to RL, LLMs are not trained on any data. Like, you LLM people have billions of dollars and zero data. I train on more data on one server than OpenAI uses for all of pre-training. I don't think it's like, oh, they just need too much data. Let's see.
So the model should be good at competitive programming. So let's get every single competitive programming problem ever, And then let's do some data augmentation so we have even more competitive programming problems,
Yes.
and we train on that. And so now you got this great competitive programmer. And with this analogy, I think it's more intuitive. I think it's more intuitive with this analogy that, yeah, okay, so if it's so well trained, okay, it's like all the different algorithms.
Oh, okay. So yes, I can see why that's a problem with language models, I guess. Well, how much data is that? Does anybody know? Like, how much does it cost to RL fine-tune on every competitive programming problem ever? Because, you know, from the amount of data I'm used to, that's just no data. So, like, my mind just immediately goes, oh, that's free. But maybe that is millions or tens of millions of dollars for each new thing you want to solve. Like, the approach I have with Puffer is fundamentally different, because we do basically do the equivalent of let's train on every competitive programming problem ever. It's just that we do it instantly on one machine because everything is so fast, right? And we scale data, we don't scale model size or compute anywhere near as hard.
And all the different proof techniques are like right at its fingertips. And it's more intuitive that with this level of preparation, it would not necessarily generalize to other things.
Hmm. But then what is the analogy for what the second student is doing before
Billion tokens,
they do
which is
the 100
nothing.
hours
4
of
terabytes.
fine-tuning?
I think it's like they have it. I think it's the it factor.
Yeah.
Right. And like I know, like when I was an undergrad, I remember there was a student like this that studied with me. So I know it exists.
Yeah. I think it's interesting to distinguish it from whatever pre-training does. So one way to understand what you just said about we don't have to choose the data in pre-training is to say, actually, it's not dissimilar to the 10,000 hours of practice. It's just that you get that 10,000 hours of practice for free because it's already somewhere in the pre-training distribution. But it's like, maybe you're suggesting actually, there's actually not that much generalization in pre-training. There's just so much data in pre-training. But it's like, it's not necessarily generalizing better than RL.
Like the main strength of pre-training is that there is
Pre-training generalizing better than RL. Well, that's hard to quantify.
so much of it.
Yeah.
Meaningless.
And B, you don't have to think hard about what data to put into pre-training.
Put everything.
And it's a very kind of natural data.
Well, not really. Like, it's language data, right? And this is actually one of the big limitations, right? Which is why I say, hey, LLMs will never solve this problem or that. Like, why the hell would you ever plug a language model into drone control, right? It's like some fiddly, unintuitive, low-level optimization problem. You're not going to just put raw RAM states from everything into a language model, right? You're not going to just byte model everything.
And it does include in it a lot of what people do.
Anthropic is the worst when it comes to hype. Anthropic, when Anthropic split off from OpenAI, originally it was just all the crazy people leaving.
Yeah.
People's thoughts and a lot of the features of, it's like the whole world as projected by people onto text.
Yeah.
And pre-training tries to capture
The whole world. There are very, very substantial gaps in that. There is important data that is not projected into text, and that is one of the key things I'm doing with RL, right? Like, RL is good for fiddly, unintuitive optimization problem. The stuff I'm doing will never be good on its own for just processing text in the way a language model is, right? Maybe some of the stuff I come up with ends up informing algorithms over there, but the approach I'm taking will never directly one-to-one. But similarly, I don't see how LLMs ever one-to-one this other thing. So I do think that there is a gap.
that using a huge amount of data. It's very, the pre-training is very difficult to reason about because it's so hard to understand the manner in which.
Oh, Son of Liberty. It's like, it's way worse than that. So when I was doing Neural MMO, I had one of the early guys who joined Anthropic super early talk to me, and he said, actually, we are afraid of your like little single PhD 1 GPU RL project. Like, your Neural MMO stuff is super scary. Also, if you wanted to like consider joining Anthropic early, you should know that like all the equity is matched is locked up in donation matching because, we're not going to do this to get rich. And the guy telling me this was somebody who'd retired off of trading in his 20s. It was like just crazy out of touch people.
The model relies on pre-training data. And whenever the model makes a mistake,
Yeah, LMs will be a
could
huge
it be
change.
because something by chance is not as supported by the pre-training data? And support by pre-training is maybe a loose term. I don't know if I can add anything more useful on this, but I don't think there is a human analog to pre-training.
Here's analogies that people have proposed.
I don't think there is a human analog to pre-training. Yeah, evolution is the one that I use, but it's not remotely a one-to-one at all. Like, it's a really, really bad analogy. It's better than no analogy, but it's a really bad one.
For what the human analogy to pre-training is, and I'm curious to get your thoughts on why they're potentially wrong. One is
Not answering off-topic questions during this, Liberty.
to think about the first 18 or 15 or 13 years of a person's life when they aren't necessarily economically productive, but they are doing something that is making them understand the world better and so forth. And the other is to think about evolution as doing some kind of search for 3 billion years, which then results in a human lifetime instance. And then I'm curious if you think either of these are actually analogous to pre-training, or how would you think about at least what lifetime human learning is like, if not pre-training?
I think there are some similarities
Yeah.
between both of these two pre-training,
Yeah.
and pre-training tries to play the role of both of these. But I think there are some big differences as well. The amount of pre-training data is very, very staggering.
Yes.
And somehow a human being, after even 15 years with a tiny fraction of that pre-training data, they know much less.
Yeah.
But whatever they do know, they know much more deeply, somehow. And the mistakes,
Yeah, see, Ilya just says what I say, but way
you would
better.
not make mistakes that RAIs make.
Yeah.
There is another thing. You might say, could it be something like evolution? And the answer is maybe. But in this case, I think evolution might actually have an edge. Like, there is this, I remember reading about this case where that one thing that neuroscientists do, or rather, one way in which neuroscientists can learn about the brain is by studying people with brain damage to different parts of the brain.
Mm-hmm.
And some people have the most strange symptoms you could imagine. It's actually really, really interesting. And there was one case that comes to mind that's relevant. I read about this person who had some kind of brain damage that took out, I think, a stroke or an accident that took out his emotional processing. So he stopped feeling any emotion. And as a result of that, he still remained very articulate and he could solve little puzzles, and on tests he seemed to be just fine. But he felt no emotion. He didn't feel sad. He didn't feel angry. He didn't feel animated. And he became somehow extremely bad at making any decisions at all. It would take him hours to decide on which socks to wear, and he would make very bad financial decisions. And that's very... what does it say about the role of our built-in emotions in making us like a viable agent, essentially? And I guess to connect to your question about
Yes.
pre-training, it's like
That seems apocryphal.
maybe maybe if you are good enough at like getting everything out of pre-training, you could get that as well. But that's the kind of thing which seems, well, it may or may not be possible.
Pre-training
to
is
get
not
that
enough, I agree.
from pre-training.
What is that? Clearly not just directly emotion. It seems like
Yeah, but like Ilya
some
knows that, Liberty, dude. Come on.
almost value function like thing, which is telling you which decision to be made, like what the end reward for any decision should be. And you think that doesn't sort of implicitly come from...
I think it
Pre-training
could.
doesn't have
I'm just saying
interaction.
it's not 100% obvious.
Yeah. But what is that? Like, how do you think about emotions? And what is the ML analogy for emotions?
It should be some kind of a value function thing.
Yeah.
But I don't think there is a great ML analogy because right now value functions don't play a very prominent role in the things people do.
It might be worth defining for the audience what a value function is if you want to do
The
that.
thing
I
you
mean,
can't learn in
certainly,
LLMs,
I'll be
which
very
is
happy
why
to do
your
that.
RL doesn't work.
Right. So when people do reinforcement learning, the way reinforcement learning is done right now, how do people train those agents? So you have your neural net and you give it a problem and then you tell the model go solve it. And the model takes maybe thousands, hundreds of thousands of actions or thoughts or something, and then it produces a solution. The solution is graded. And then the score is used to provide a training signal for every single action in your trajectory.
Mm-hmm.
So that means that if you are doing something that goes for a long time, if you're training a task that takes a long time to solve, you will do no learning at all until you came up with a proposed solution. That's how reinforcement learning is done naively. That's how O1, R1 ostensibly are done. The value function says something like, okay, look, maybe I could sometimes, not always, could tell you if you are doing well or badly. The notion of a value function is more useful in some domains than others. So for example, when you play chess
It's critical
and you lose a piece,
in
I messed up.
most of what we have. To be fair,
You
there are
don't
some
need
ends
to
that
play
don't
the
need
whole
it.
game to know that
Right.
what I just did was bad, and therefore whatever
RL doesn't
whatever
work without value
preceded it
functions,
was
which
also
is why
bad.
LLM-RL is such a
So the
meme.
value function lets you short circuit the wait until the very end. Like, let's suppose that you started to
Eccentric.
pursue some kind of okay, let's suppose that you are doing some kind of a math thing or a programming thing, and you're trying to explore a
Illy is good
particular solution
eccentric.
direction. And after, let's say, after 1,000 steps of thinking, you concluded that this direction is unpromising. As soon as you conclude this, you could already get a reward signal 1,000 time steps previously when you decided to pursue down this path. You say, oh, next time I shouldn't pursue this path in a similar situation, long before you actually came up with a proposed solution.
This was in the DeepSeek R1 paper, is that the space of
Don't need
trajectories is
LLM lit.
so wide
Dude, it's in like classic
that maybe
RL
it's
lit
hard to
from a
learn
decade
mapping
ago.
from an intermediate trajectory
Realistically, much more than a
and
decade ago.
value. And also given that, in coding, for example, you'll have the wrong idea, then you'll go back, then you'll change something.
This sounds like such lack of faith in deep learning.
Yeah.
Like, I mean, sure, it might be difficult, but nothing deep learning can't do.
Yeah.
So my
Yeah.
expectation is that like value functions should be useful, and
Yes.
I fully expect that they will be used in the future, if not already. What was I alluding to with the person whose emotional center got damaged is more that maybe what it suggests is that the value function
Eccentric. This is because I had the chance to talk to him at many lunches when I was an intern at OpenAI, and he was one of the most brilliant people I've ever met. I don't say that lightly. Like, I would not say the same thing about Sam Altman, or even some of the other people at OpenAI, though many of them were very, very good. Him, Greg Brockman, Alec Radford, on algorithm side at the very least, Schulman, were very smart people.
of humans is modulated by emotions in some important way that's hard-coded by evolution. And maybe that is important for people to be effective in the world.
That's the thing I was actually planning on asking you. There's something really interesting about emotions of the value function, which is that it's impressive that they have this much utility while still being rather simple to understand.
So I have two responses. I do agree that compared to the kind of things that we learn and the things we are talking about, the kind of as we are talking about, emotions are relatively simple. They might even be so simple that maybe you could map them out in a human understandable way. I think it would be cool to do. In terms of utility, though, I think there is a thing where, there is this complexity robustness trade-off, where complex things can be very useful, but simple things are very useful in a very broad range of situations. And so I think what one way to interpret what we are seeing is that we've got these emotions that essentially evolved mostly from our mammal ancestors, and then fine-tuned a little bit while we were hominids, just a bit. We do have like a decent amount of social emotions though, which mammals may lack, but they're not very sophisticated. And because they're not sophisticated, they serve us so well in this very different world compared to the one that we've been living in. Actually, they also make mistakes. For example, our emotions, well, I don't know, does hunger count as an emotion? It's debatable, but I think, for example, our intuitive feeling of hunger is not succeeding in guiding us correctly in this world with an abundance of food.
Yeah. People have been talking about scaling data, scaling
Okay, I
parameter,
actually
scaling
kind of like
compute.
this is a weird tangent, but like
Is there a more general way to think about scaling? What are the other scaling axes?
So the thing, here is a perspective. Here's a perspective that I think might be true. So
it actually does
the
kind of make
way
sense if you're
ML
thinking
used to
about RL
work
though.
is that people would just tinker with stuff and try to get interesting results.
That's
That's
still
what's
how
been
it
going on in
works.
the past. Then the
Still
scaling
how it works.
insight arrived, right? Scaling laws, GPT-3, and suddenly everyone realized we should scale. And it's just
Oops,
this
I
is
didn't
an
get the memo.
example of how language affects thought. Scaling is just one word, but it's such a powerful word because it informs people what to do. They say, okay, let's try to scale things.
Go scale the wrong
And so you
shit.
say, okay, so what are we scaling?
Yeah.
And pre-training was a thing to scale. It
Yeah.
was a particular scaling recipe.
Yes.
The big breakthrough of pre-training is the realization that this recipe is good. So you say, hey, if you
Yeah.
mix some compute with some data into a neural net of a certain size, you will get results, and you will know that it will be better if you just scale the recipe up. And this is also great. Companies love this because it gives you a very low risk way of investing
Yeah.
your resources.
Yeah.
Right? It's much harder to invest your resources in research. Compare that. If you research, you need to have go forth researchers and
connect with
research
RL?
and come up with something.
Because just like they're basically a bunch of super simple heuristics that you can use in pretty much any new environment, and it's very difficult to get agents to learn anything that looks like those heuristics. Like, yeah. So it's kind of a weird tangent addressed in a way that makes more sense than because normally it's like a totally stupid tangent. This one's like, okay, that's kind of sure.
Versus
He's thinking
get
about
more
RL.
data, get more compute, you'll get something from pre-training. And indeed, it looks like based on various things some people say on Twitter, maybe it appears that Gemini have found a way to get more out of pre-training. At some point, though, pre-training will run out of data. The data is very clearly finite. And so then, okay, what do you do next? Either you do some kind of souped up pre-training, different recipe from the one we've done before, or you're doing RL, or maybe something else. But now that compute is big, compute is now very big, in some sense, we are back to the age of research. So maybe here's another way to put it. Up until 2020, from 2012 to 2020, it was the age of research.
Pretty much, yes.
Now, from 2020 to 2025, it was the age of scaling.
I gotta say, Puffer-eccentric.
Let's add error bars to those years. Because people say, this is amazing, you gotta scale more, keep scaling, the one word, scaling. But now the scale is so big, is the belief really that, oh, it's so big, but if you had 100x more, everything would be so different? It would be different for sure.
Yeah.
But is the belief that if you just 100x the scale, everything would be transformed? I don't think that's true. So it's back to the age of research again, just with big computers.
That's a very interesting way to put it.
Research is really inefficient with big computers, though.
What are we scaling, and what would it mean to have a recipe? Because
Puffer.ai eccentric, big open source project.
A very clean
we got demos
relationship that almost looks like a law of physics, which existed in pre-training. There's a power law.
We do tiny models with a ton of data.
Computer parameters and
more data than
laws.
they have.
What is the kind of relationship we should be seeking, and how should we think about what this new recipe might look like?
So we've already witnessed a transition from one type of scaling to a different type of scaling, from pre-training to RL.
Scale more
Now
RL.
people are scaling RL. Now based
Scale
on
the number of stars
what
on
people say on
Pufferlib. Go star
Twitter,
the Puffer
they
repo.
spend more
It's
compute
free.
on RL than on pre-training at this point, because RL can actually consume quite a bit of compute.
Yeah.
You
Help
know, you
us
do
scale
very, very
RL.
long rollouts.
Yes.
So it takes a lot of compute to produce those rollouts. And then you get relatively small amount of learning per rollout. So you
Right.
really
Fun fact. I literally, on the monitor behind me, have 40,000 years worth of gameplay RL experiments that I've been running over time. Yeah, we have, that's like, I think that's like 20 petabytes uncompressed. Yeah, we got lots of data, so we know what to scale there.
you really can spend a lot of compute. And
One
I
server.
could imagine, like I wouldn't at this it's more like I wouldn't even call it a scaling. I would say, hey, like what are you doing? And is the thing you are doing the most productive thing you could be doing?
Yes.
Can you find a more productive way of using your compute? We've discussed the value function business earlier, and maybe once people get good at value functions, they will be using their resources more productively. And if you find a whole other way of training models, you could say, is this scaling or is it just using your resources? I think it becomes a little bit ambiguous, in a sense that when people were in the age of research, back then it was like people say, hey, let's try this and this and this. Let's try that and that and that. Oh, look, something interesting is happening. And I think there will be a return to that.
So if we're back in the era of research, stepping back, what is the part of the recipe that we need to think most about? When you say value function, people are already trying the current recipe, but then having LLM as a judge and so forth. You could say that's a value function, but it sounds like you have
That's
something
a
much more
really shit
fundamental in
value
mind.
function.
Do we need to go back to
It's such a bad value
should we even
function.
rethink pre-training at all and not just add more steps to the end of that process?
Yeah. So the discussion about value function, I think it was interesting. I want to like emphasize that I think the value function is something like it's going to make RL more efficient. And I think that makes a
Yeah.
difference. But I think that anything you can do with a value function, you can do without, just more slowly.
Mm-hmm.
Way more slowly.
The
Not a
thing which I
constant
think is the
factor.
most fundamental is that these models somehow just generalize dramatically worse than people.
Yes.
And it's super obvious. That seems like a very fundamental thing.
Okay. So this is the crux, generalization. And there's two sub questions. There's one which is about sample efficiency, which is why should it take so much more data for these models to learn than humans? There's a second about even separate from the
I have
amount
the
of data it
opposite
takes.
bet.
There's a question of why is it so
We have
hard to
infinite data.
piece the thing we want to a model than to a human, which is to say, to a human, we don't necessarily need a verifiable reward to be able to. You're probably mentoring a bunch of researchers right now, and you're talking with them, you're showing them your code, and you're showing them how you think, and from that, they're picking up your way of thinking and how they should do research. You don't have to set like a verifiable reward for them that's like, okay, this is the next part of the curriculum, and now this is the next part of your curriculum, and oh, it was
Try to write
this
down
training was unstable, and there's not this schleppy bespoke process. So perhaps these two issues are actually related in some way, but I'd be curious to explore this second thing, which feels more like continual learning, and this first thing, which feels just like sample efficiency.
Yeah. So you could actually wonder one possible explanation for the human sample efficiency that needs to be considered is evolution.
Yeah, that's what I always
And
say. Humans are not tabula
Evolution
rasa.
has given us a small amount of the most useful information possible. And for things like vision, hearing, and locomotion, I think there's a pretty strong case that evolution actually has given us a lot.
Mm-hmm.
So, for example, human dexterity far exceeds, robots can become dexterous too if you subject them to like a huge amount of training and simulation.
Superhuman.
But to train a robot in the real world to quickly like pick up a new skill like a person does seems very out of reach.
Yeah.
And here you could say, oh yeah, like locomotion all our ancestors needed great locomotion, squirrels, like, so locomotion
Yeah.
maybe, like we've got like some unbelievable prior.
Yeah.
You could make
Yeah.
the same case for vision. You know, I believe Jan LeCun made the point, oh, like children learn to drive after like 10 hours of practice, which is true. But our vision is so good.
Yeah.
At least for me, when I remember myself being 5-year-old,
Yeah.
I was very excited about cars back then, and I'm pretty sure my car recognition was more than adequate for self-driving already as a 5-year-old. You don't get to see that much data as a 5-year-old. You spend most of your time in your parents' house, so you have very low data diversity.
Yeah.
Yeah.
But you could say maybe that's evolution too. But in language and math and coding, probably not.
It still seems better than models. I mean, obviously, models are better than the average human at language and math and coding, but are they
Yeah.
better at the average human at learning?
Oh yeah, absolutely. What I meant to say is that language, math, and coding, and especially math and coding, suggests that whatever it is that makes people good at learning is probably not so much a complicated prior, but something more, some fundamental thing.
Wait, I'm not sure I understood. Why should that be the case?
So consider a skill that people exhibit some kind of great reliability or,
Yeah.
if the skill is one that was very useful to our ancestors for many millions of years, hundreds of millions of years, you could argue that maybe humans are good at it because of evolution, because we have
Okay,
a
yeah.
prior,
Yeah.
an evolutionary prior that's encoded in some very non-obvious way
Yeah.
that somehow makes us so good at it.
Yeah.
But if people exhibit great ability, reliability, robustness, ability to learn in a domain that really did not exist until recently, then this is more an indication that people might have just better machine learning, period.
Mm-hmm.
Kind of have to
But then how should
deconstruct
we
the
think
domain.
about what that is? Is it a matter
bit.
of, yeah, what is the ML analogy for what? There's a couple interesting things about it. It takes fewer samples. It's more unsupervised. You don't have to set like a child learning to drive a car. Children are not learning to drive a car. A teenager learning how to drive a car is like not exactly getting some pre-built verifiable reward. It comes from their interaction with the machine and with the environment. And yeah, it takes much fewer samples. It seems more unsupervised. It seems more robust.
Much more robust. The robustness of
It's
people
not. Wait.
is really
It's like you already have autonomous vehicles better than the average driver. They take way more data, but the ceiling is way higher. Like, even in a decade, we're gonna look back like, oh wait, what the hell? We have people driving cars. Okay, maybe the bureaucracy will take longer than that, but like, yeah, you definitely can get way more robustness out of models. Like, non-language models, RL models, yeah, way more robustness than people have, but it takes a ton of data. That's the difference.
staggering.
Yeah. So is it like, okay.
In the
and
context
do you
of
have a
language
unified way of
models, that's
thinking
true,
about
though.
Why are all these things happening at once? What is the ML analogy that could realize something like this?
So this is where, one of the things that you've been asking about is how can, the teenage driver kind of self-correct and learn from their experience
Yeah.
without an external teacher? And the answer is, well, they have their value function,
Yeah.
right? They have a general sense, which is also, by the way, extremely robust in people. Like, whatever it is,
Yeah,
the
because you
human
use
value
the
function,
reward to train
whatever
the
the
value
human value
function.
function
Value
is,
function is the
with
policy.
a few exceptions around addiction, it's actually very, very robust. And
It's a
so for
longer
something like
question.
a teenager that's learning to drive, they start to drive and they already have a sense of how they're driving immediately,
Mhm.
how
Yeah, it's
badly
not
they're
learning.
confident. And then they see, okay, and then of course the learning speed of any teenager is so fast. After 10 hours, you're good to go.
Yeah. It seems like humans have some solution, but I'm curious about like, well, how are they doing it, and like, why is it so hard?
I get to go do
like,
that in a month
how
or
do we
two
need to
because I
reconceptualize
never
the way we're
bothered to
training
do it.
models to make something like this possible?
That is a great question to ask. And it's a question I have a lot of opinions about. But unfortunately, we live in a world where not all machine learning ideas are discussed freely, and this is one of them. So there's probably a way to do it. I think it can be done. The fact that people are like that, I think it's a proof that it can be done. There may be another blocker though, which is there is a possibility that
Yeah.
the human neurons actually do more compute than we think. And
Eh,
if that is true,
that'd be
and
funny.
if that plays an important role, then things might be more difficult. But regardless, I do think it points to the existence of some machine learning principle that I have opinions on, but unfortunately, circumstances make it hard to discuss in detail. Even though
Nobody
That's
listens
why
to
you
this
raise
podcast
money,
anyways.
man. Gotta keep everything
So
secret.
I have to say that prepping for Ilya was pretty tough because neither I nor anybody else had any idea what he's working on and what SSI is trying to do. I had no basis to come up with my questions. And the only thing I could go off, honestly, was trying to think from first principles about what are the bottlenecks to AGI, because clearly Ilya is working on them in some way. Part of this question involved thinking about RL scaling because everybody's asking how well RL will generalize and how we can make it generalize better. As part of this, I was reading this paper that came out recently on RL scaling, and it showed that actually the learning curve on RL looks like a sigmoid. I found this very curious. Why should it be a sigmoid where it learns very little for a long time and then it quickly learns a
Reload,
lot
dude.
and then it asymptotes? This is very different from the power law you see in pre-training where the model learns a bunch at the very
Alright, you
beginning
got the metric
and then
wrong,
less
dude.
and less over time. And it actually reminded me of a note that I had written down after I had a conversation with a researcher friend where he pointed out that the number of samples that you need to take in order to find a correct answer scales exponentially with how different your current probability distribution is from the target probability distribution. And I was thinking about how these two ideas are related. I had this vague idea that they should be connected, but I really didn't know how. I don't have a math background, so I couldn't really formalize it. But I wondered if Gemini 3 could help me out here. And so I took a picture of my notebook, and I took the paper and I put them both in the context of Gemini 3, and I asked it to find the connection. And it thought a bunch, and then it realized that the correct way to model the information you gain from a single yes or no outcome in RL is as the entropy of a random binary variable. It made a graph which showed how the bits you gain per sample in RL versus supervised learning scale as the pass rate increases. And as soon as I saw the graph that Gemini 3 made, immediately a ton of things started making sense to me. Then I wanted to see if there's any empirical basis to this theory. So I asked Gemini to code an experiment to show whether the improvement in loss scales in this way with pass rate. I just took the code that Gemini outputted, I copy pasted it into a Google Colab notebook, and I was able to run this toy ML experiment and visualize its results without a single bug. It's interesting because the results look similar but not identical to what we should have expected. And so I downloaded this chart and I put it into Gemini and I asked it, what is going on here? And it came up with a hypothesis that I think is actually correct, which is that we're capping how much supervised learning can improve in the beginning by having a fixed learning rate. And in fact, we should decrease the learning rate over time. It actually gives us an intuitive understanding for why in practice we have learning rate schedulers that decrease the learning rate over time. I did this entire flow from coming up with this vague initial question to building a theoretical understanding to running some toy ML experiments, all with Gemini 3. This feels like the first model where it can actually come up with new connections that I wouldn't have anticipated. It's actually now become the default place I go to when I want to brainstorm new ways to think about a problem. If you want to read more about RL scaling, you can check out the blog post that I wrote with a little help from Gemini 3. And if you want to check out Gemini 3 yourself, go to gemini.google. I am curious,
Oh,
you say we are back.
I let the ad play, and that was the most effective possible ad for not outsourcing your thinking that anyone could have given me. It's very simple. If you outsource your thinking, you have zero value. That's it.
In an era
You
of
come up with shit
research.
like that.
You were there from 2012 to 2020. And do you have, yeah, what is now the vibe going to be if we go back to the era of research? For example, even after AlexNet, the amount of compute that was used to run experiments kept increasing, and the size of frontier systems kept increasing. And do you think now that this era of research will still require tremendous amounts of compute? Um, do you think it will require going back into the archives and reading old papers? What is maybe what was the vibe of like you were at Google and OpenAI and Stanford, these places when there was like a more of a vibe of research? What kind of things should we be expecting in the community?
So one
Expect RL to
consequence
work in the
of
next year or two
the
for
age
small
of
models
scaling is
with
that
tons
there
of
was
data,
this
exabytes.
scaling sucked out all the air in the room.
Yeah.
Yep.
And
This is precisely my complaint about LLMs. All right, LLMs are awesome. They should take up 80% of the resources, not 99. There are literally fewer resources for RL now than before all of the language model boom, despite the huge amount of extra money injected by that, because it's all gone to scaling bullshit. Like, pretty much all of the smartest people I know in RL as well, they no longer do it. They now work at language model companies that pay them a lot of money. So, woe and behold, zero progress got made in RL from 2019 till 2024.
so because scaling sucked out all the air in the room, everyone started to do the same thing. We got to the point where we are in a world where there are more companies than ideas by quite a bit. Actually, on that, there is this Silicon Valley saying that says that ideas are cheap,
Yeah.
execution is everything.
Yeah.
And people say that a lot.
Yeah.
And there is truth to that. But then I saw someone say on Twitter something like, if ideas are so cheap, how come no one's having any ideas?
I got ideas.
And I think it's true too. I think, like, if you think about a research progress in terms of bottlenecks, there are several bottlenecks.
Your hard
If you go
speed
back
for
to
RL.
one of them is ideas, and one of them is your ability to bring them to life.
Yeah.
Which might be compute, but also engineering.
Yep, pure
So
eng,
if you go
pure
back to
hard
the
eng
90s,
fail.
let's say, you
That
had
was
people
RL
who
in a
had
nutshell.
pretty good
We
ideas.
killed her on field.
And if they had much larger computers, maybe they could demonstrate that their ideas were viable, but they could not. So they could only have very, very small demonstration that did not convince anyone.
Yeah.
Yeah, the Schmidt-Huber,
So the bottleneck was
Yamakun.
compute.
Like,
Then in the
why
age of
Schmidt-Huber is so
scaling,
mad in a nutshell, right? Because like the guy actually had a bunch of cool ideas and a bunch of cool research, and now he sees like everybody getting all this recognition for basically like copy paste same idea with more compute, right? Like he's got some merit in it as well.
compute has increased a lot. And of course, there is a question of how much compute is needed, but compute is large. So compute is large enough such that it's like not obvious that you need that much more compute to prove some idea. Like, I'll give you an analogy. AlexNet was built on 2 GPUs.
It was
That
my
was
first
the
paper.
total amount of compute used for it. The transformer
It was not a good paper, but
was built on 8 to 64 GPUs. No single transformer paper experiment used more than 64 GPUs of 2017, which would be like what, 2 GPUs of today? So
all right.
the ResNet,
The one cheaty thing about that is then Google has a ton of GPUs to run like a ton of experiments in parallel. So if you're in an academic lab, you're kind of just screwed because you get to run one experiment and hope it works. Like I've seen this firsthand. So up an order of magnitude or two for that.
right? Many, like even the you could argue that the like O1 reasoning
Mhm.
was not the most compute heavy thing in the world. So they're definitely for research, you need like definitely some amount of compute, but it's far from obvious that you need the absolutely largest amount of compute ever for research. You might argue, and I think it is
What I got
true,
behind me, got
that
20
if you want to
GPUs.
build the absolutely best system, then it helps to have much more compute. And especially if everyone is within the same paradigm, then compute becomes one of the big differentiators.
Yeah, I guess while it was possible to develop these ideas, I'm asking you for the history because you were actually there. I'm not sure what actually happened, but it sounds like it was possible to develop these ideas using minimal amounts of compute. But it wasn't, the transformer didn't immediately become famous. It became the thing everybody started doing and then started experimenting on top of and building on top of because it was validated at higher and higher levels of
Yeah, it's
compute.
not even clear that
Correct.
you need the
And
transformer,
if
to be
you,
honest.
SSI, have
to
50 different
scale.
ideas, how will you know which one is the next transformer and which one is
Like, honestly, it was just scale more than anything.
brittle without
Transformer's
having
good, but
the kinds of compute that other frontier labs have?
So I can comment on that, which is the short comment is that you mentioned SSI specifically for us. The amount of compute that SSI has for research is really not that small, and I want to explain why. Like a simple math can explain why the amount of compute that we
More
have
experiments
is
in
actually a
parallel?
lot more comparable for research than one might think. And I'll explain. So SSI has raised $3 billion, which is like
a lot of
not
money,
small,
dude.
but it's like a lot by any absolute sense. But you could say, but look at the other companies raising much more. But a lot of their compute goes for inference.
Yeah.
Like these
They're
big
just using it for
numbers, these big
research.
loans, it's earmarked for inference. That's number one. Number two, if you want to have a product on which you do inference, you need to have a big staff of engineers, of salespeople. A lot of the research needs to be dedicated for producing all kinds of product related features. So then when you look at what's actually left for research, the difference becomes a lot smaller.
Yeah, he's very happy he got
Now,
unlimited budget to
the
do
other
research in
thing
peace.
is that if you are doing something different, do you really need the absolute maximal scale to prove it? I don't think that's true at all. I think that in our case, we have sufficient compute to prove, to convince ourselves and anyone else that what we're doing is correct.
Yep.
There's been public estimates that companies like OpenAI spend on the order of $5-6 billion a year, even just so far on experiments.
Mhm.
Google's the
This
most
is separate
bloated
from
company
the amount of money they're
imaginable.
spending on inference and so forth. So it seems like they're spending more a year running research experiments
You can be 100x
than you guys have in total funding.
more efficient than
I
Google
think it's a
easily.
question of what you do with it. It's a question of
Yeah.
what you do with it. Like they have the more, I think in their case, in the case of others, I think there's a lot more demand on the training compute. There's a lot more different work streams. There are different modalities. There is just more stuff. And so it becomes fragmented.
How will SSI make money?
You know, my answer to this question is something like right now we just focus on the research, and then the answer to that question will reveal itself. I think there will be lots of possible answers.
That is chill.
Is SSI's plan still to straight shot superintelligence?
Maybe.
Maybe.
I think that there is merit to it. I think there's a lot of merit because I think that it's very nice to not be affected by the day-to-day market competition. But I think there are two reasons that may cause us to change the plan. One is pragmatic, if timelines turned out to be long, which they might. And second, I think there is a lot of value in the best and most powerful AI being out there impacting the world.
Yeah.
Yeah.
I think this is a meaningfully valuable thing.
Yeah.
But then, so why is your default plan to straight shot superintelligence? Because it sounds like, OpenAI, Anthropic, all these other companies, their explicit thinking is, look, we have weaker and weaker intelligences that the public can get used to and prepare for. And why is it potentially better?
Yeah, but clearly, like, these
build the
companies aren't really
superintelligence
doing
directly?
anything. They're no
So
longer
I'll make
innovating.
the case for and against.
Yeah.
The case for is that one of the challenges that people face when they're in the market is that they have to participate in the rat race.
Yeah.
And the rat race is quite
Winner of the rat
difficult
race
in
is
that
a
it
rat.
exposes you to difficult trade-offs which you need to
Favorite
make.
saying.
And it is nice to say we'll insulate ourselves from all this and just focus on the research and come out only when we are ready and not before. But the counterpoint is valid too. And those are opposing forces. The counterpoint is, hey, it is useful for the world to see powerful AI. It is useful for the world to see powerful AI. because that's the only way you can communicate it.
Well, I guess not even just that you
I had
can
to thread that
communicate the
needle with
idea,
Puffer
but
at
communicate the
obviously
AI.
way smaller scale.
Not the idea. Communicate the AI.
what do you mean communicate the AI?
So okay, so let's
So what it can
suppose you
do,
read
right?
an essay about AI.
Yeah.
And the essay says AI is going to be this, and
Yeah.
AI is going to be that, and it's going to be this.
Yeah, yeah.
And you read it and you say, okay, this is an interesting essay.
Right.
Now suppose you see an AI doing this, an AI doing that. It is incomparable.
Yeah.
Like basically, I think that
This is why
there
RL,
is
like, I don't
a
even
big
care.
benefit
Because people are going to see it in a
from
couple
AI
years.
being in the public.
And I don't have to
and
convince anybody. They'll see it in a couple
That
years.
would be a reason for us to not be quite straight shot.
Well, I guess it's not even that, but I do think that is an important part of it. The other big thing
Means
is
they're going to show us some
I
stuff.
can't think of another discipline in human engineering and research where the end artifact was made safer mostly through just thinking about how to make it safe, as opposed to why are airplane crashes per mile so much lower today than they were decades ago? Why is it so much harder to find a bug in Linux than it would have been decades ago? And I think it's mostly because these systems were deployed to the world. You noticed failures, those failures were corrected, and the systems became more robust. Now, I'm not sure why AGI and superhuman intelligence would be any different, especially given, and I hope we can talk, we're going to get to this. It seems like the harms of superintelligence are not just about like having some malevolent paperclipper out there, but it's just like, this is a really powerful thing, and we don't even know how to conceptualize how people will interact with it, what people will do with it, and having
Okay,
gradual access to
fair.
it seems like a
This is probably
better
my
way to
main
maybe spread out
disagreement with
the
Ilya is like,
impact
pro
of it
open
and
source
how people prepare
everything.
for it.
Well, I think on this point, even in the straight shot scenario, you would still do a gradual release of it. Is how I would imagine it.
Also fair.
The gradualism would be an inherent component of any plan. It's just a question of what is the first thing that you get out of the door. That's number one. Number two, I also think, I believe you have advocated for continual learning more than other people.
Yeah.
And I actually think that this is an important and correct thing. And here is why.
Puffer's
so one
every-
of the things
Puffer is everything in RL except LLMs. We do small superhuman models specialized to everything from games, drones, autonomous driving. We just released compute simulator, compute marketplace sim, done other stuff with other companies. We build high performance custom sims and then train tiny models on petabytes or more of data.
So I'll give you another example of how language affects thinking. And in this case, this will be two words.
All open
Two
source.
words that have shaped everyone's thinking, I maintain. First word, AGI. Second word,
Yeah.
pre-training. Let me explain. So
I'm
term AGI,
susceptible to one of these.
why does this term exist?
Cool.
It's a very particular term. Why does it exist?
Oh,
There's
do
a
I get to
reason.
link my article?
The reason that the term AGI exists is, in my opinion, not so much because it's like a very important, essential descriptor of some end state of intelligence, but
Motivator.
because it is a reaction to a different term that existed, and the term is narrow AI. If you go back to ancient history of game playing AI, of checkers AI, chess AI, computer games AI, everyone would say, look at this narrow intelligence. Sure, the chess AI can beat Kasparov, but it can't do anything else. It is so narrow, artificial narrow intelligence. So in response, as a reaction
Actually,
to this, some people said, well, this is not good. It is so narrow. What we need is general AI.
yeah, see, so my response to this is, okay, screw it. I'm going to make these narrow superhuman AIs that you can train on one GPU at home and make it stupidly easy to do this across a huge number of domains. And I'm going to do it without needing any funding because it's so cheap.
General AI, an AI that can just do all the things. The second, and that term just got a lot of traction.
Yeah.
The second thing that got a lot of traction is pre-training. Specifically, the recipe of pre-training. I think the way people do RL now is maybe undoing the conceptual imprint of pre-training.
Not text
But
liberty.
pre-training has a
Doesn't matter.
property. You do more pre-training,
Not
and the
initially, at
model
least.
gets better at everything, more or less uniformly.
Yeah.
General AI. Pre-training gives AGI. But the
You can do
thing
this with RL
that
too.
happened with AGI and
So my alternative model for AGI, and this is what I pitched to him while I was at OpenAI, is instead of doing supervised learning, just build like a ridiculously big and complex sim that encompasses all the things you actually care about, make it super fast, and just chug through huge amounts of data. I think that probably we would not be as far if he'd listened to me on that one as we are today in AI as a whole. But I think we are missing something long term that that approach will give us. And that's kind of what I'm demonstrating lately through all the RL that I've been doing, right? Like these guys keep spending more and more and more money. And I'm on the other hand spending less and less and less money because it's getting faster and faster and faster for better and better capabilities.
pre-training is that in some sense they overshot the target.
He just had a bigger bet on like compress everything. It was compression at the time was the idea. Right? Like what if we just compress everything? What about compression as learning?
Because by the kind
Liberty, you could, but like text is really obnoxious because you tend to need a bigger model to process the inputs. It's like how you need a bigger model to process pixels, but on a much different scale.
and if you think about the term AGI, you will realize, and especially in the context of pre-training, you will realize that a human being is not an AGI. Because a human being, yes, there is definitely a foundation of skills.
All right. Look. The definition of AI or AGI has been settled. I got sick of all the AGI discussions at lunch at OpenAI, so I came up with this definition. Maybe a couple of the people remember it. Maybe it's too ridiculous to. But where is it? You can read this on X. There's AGI when I can cast Fireball. There you go. That's the definition.
A human being lacks a huge amount of knowledge. Instead, we rely on continual learning. And so then when you think about, okay, so let's suppose that we achieve success and we produce some kind of safe superintelligence. The question is, but how do you define it? Where on the curve of continual learning is it going to be? I produce like
This thing.
a super intelligent 15-year-old that's very eager to go, and you say, okay, I'm going to
Make sci-fi
you don't
real.
have very much at all. The great student, very eager. You go and be a programmer. You go and be a doctor.
Hello,
Go
AGI.
and learn.
Please solve
So you can
cancer
imagine
and
that the
aging and
deployment
scarcity.
itself will involve some kind of a learning trial and error period.
There you go. There's your bar.
It's a process, as opposed to you drop the finished thing.
Okay, I see. So you're suggesting that the thing you're pointing out with superintelligence is not some finished mind which knows how to do every single job in the economy. Because the way, say, the original, I think, OpenAI charter or whatever defines AGI is like it can do every single job every single thing a human can do. You're proposing instead a mind which can learn to do every single job.
Yes.
And that is superintelligence. And then, but once you have the learning algorithm,
Doing
it gets
every job is
deployed into the
boring,
world
man.
The same way a human laborer might
Take us
join
into
an
sci-fi
organization.
era where bets are
And
off.
It seems like one of these two things might happen. Maybe neither of these happens.
I don't give a shit
One,
about automating existing work.
This super efficient learning algorithm becomes
I'm here for
superhuman,
sci-fi tech.
becomes as good as you, and potentially even better at the task of ML research.
Off
And as a
topic,
result,
Hyper.
the algorithm itself becomes more and more superhuman. The other is, even if that doesn't happen, if you have a single model, this is explicitly your vision. If you have a single model or instances of a model which are deployed through the economy, doing different jobs, learning how to do those jobs, continually learning on the job, picking up all the skills that any human could pick up, but actually picking them all up at the same time and then amalgamating the learnings. You basically have a model which functionally becomes super intelligent, even without any sort of recursive self-improvement in software, right? Because you now have one model that can do every single job in the economy, and humans can't merge our minds in the same way. And so do you expect some sort of
That's
like
still
intelligence
not it.
explosion from broad deployment?
I think that it is likely that we will have rapid economic growth.
Yeah. That's not
I think
interesting
the
enough
broad
on its own to
deployment,
me.
like, there are two arguments you could make, which are conflicting. One is that, look, if indeed once indeed you get to a point where you have an AI that can learn to do things quickly, and you have many of them, then there will be a strong force to deploy them in the economy, unless there will be some kind of a regulation that stops it, which, by the way, there might be.
Yeah.
But I think the
Another
idea
cool thing
of
about
very
RL,
rapid economic growth for some
can't
time,
prevent deploying
I think it's
2
very
million param
possible
models.
from broad deployment. The other question is how rapid it's going to be. So I think this is hard to know, because on the one hand, you have this very efficient worker. On the other hand, the world is just really big, and there's a lot of stuff, and that stuff moves at a different speed. But then on the other hand, now the AI could
Yeah, exactly.
You can literally, if your thing is actually AI, like an AGI and not bullshit, like I don't need more than my computer and sitting here to make a company. And like these things should be, and there are a lot of problems that can just be solved by a dude sitting at a computer who is smart enough and works long enough. So far AI has done none of this, so that'd be a good initial bar.
So I think very rapid economic growth is possible. And we will see like all kinds of things, like different countries with different rules, and the ones which have the friendlier rules, the economic growth will be faster. Hard to predict.
Some people in our audience like to read the
I'm gonna use the
transcripts
restroom.
instead of listening to the episode.
I will let
And
this
so we put
play,
a ton
but
of effort
I will do him the
into
favor of not
making the
commenting his ad.
transcripts read like they are standalone essays. The problem is that if you just transcribe a conversation verbatim using a speech-to-text model, it'll be full of all kinds of fits and starts and confusing phrasing. We mentioned this problem to Labelbox, and they asked if they could take a stab. Working with them on this is probably the reason that I'm most excited to recommend Labelbox to people. It wasn't just, oh, hey, tell us what kind of data you need and we'll go get it. They walked us through the entire process, from helping us identify what kind of data we needed in the first place, to assembling a team of expert aligners to generate it. Even after we got all the data back, Labelbox stayed involved. They helped us choose the right base model and set up auto QA on the model's output so that we could tweak and refine it. And now we have a new transcriber tool that we can use for all our episodes moving forward. This is just one example of how Labelbox meets their customers at the ideas level and partners with them through their entire journey. If you want to learn more, or if you want to try out the transcriber tool yourself, go to labelbox.com/Dwarcash. It seems to me that this is a very precarious situation to be in, where looking the limit, we know that this should be possible, because if you have something that is as good as a human at learning, but which can merge its brains, there are different instances in a way that humans can't merge. Already, this seems like a thing that should
Alright, what'd I
physically be
miss?
possible. Humans are possible. Digital computers are possible. You just need to labelbox.com/Dwarcash.
I can't shit on the ad because I don't know what it was.
It seems to me that this
You're
is
welcome.
a very precarious situation to be in, where looking the limit, we know that this should be possible, because if you have something that is as good as a human at learning, but which can merge its brains, there are different instances in a way that humans can't merge. Already, this seems like a thing that should physically be possible. Humans are possible. Digital computers are possible. You just need both of those combined to produce this thing. And it also seems like this kind of thing is extremely powerful.
No liberty.
And economic growth is one way to put it. I mean, Dyson Sphere is a lot of economic growth, but another way to put
Dyson
it is
Sphere
just
is
like,
way more exciting
you
than
will
economic
have
growth.
potentially a very short period of time.
Give me some
The human on the
sci-fi.
job can, you're hiring people at SSI in 6 months, they're like net productive probably, right? A human like learns really fast, and so this thing is becoming smarter and smarter very fast.
6 months for net
How do
productive?
you think about making that go well?
6 days
Why
or
is
get
SSI
out.
positioned to do that well?
Hours.
What is SSI's plan
take.
there, basically, is what I'm trying to ask.
Yeah. So one of the ways in which my thinking has been changing is that I now place more importance on AI being deployed incrementally and in advance. One very difficult thing about AI is that we are talking about systems that don't yet exist. And it's hard to imagine them. I think that one of the things that's happening is that in practice, it's very hard to feel the AGI. It's very hard to feel the AGI. We can talk about it,
Yeah, it's
but it's
mostly
like
there's bullshit.
it's like talking about like the long future. Like imagine like having a conversation
the
about
current
like how
stuff,
is it
yeah.
like to be old when you're like
Yeah.
old and frail, and you can have a conversation. You can try to imagine it, but it's just hard, and you come back to reality where that's not the case. And I think that a lot of the issues around AGI and its future power stem from the fact that it's very difficult to imagine. Future AI is going to be different. It's going to be powerful. Indeed, the whole problem, what is the problem of AI and AGI? The whole problem is
Yeah,
the power.
discussion feels. It's not
The whole
even
pro-
sci-fi fantasy. That would be like the cool shit. That's like what I get up in the morning because of, right? It's like, maybe we can just like solve one problem that then solves aging and disease and scarcity and like my lack of being able to cast fireball or run a 3-minute mile. Like, you know.
problem is the power. When the power is really big, what's going to happen? And one of the ways in which I've changed my mind over the past year, and so that that change of mind may I'll say I'll hedge a little bit, may back propagate into the plans of our company, is that so if it's hard to imagine,
Uh-huh.
what do? You got to be showing the thing. You got to be showing the thing. And I maintain that
Yeah.
I think most people who work on AI also can't imagine it because it's too different from what people see.
I can imagine a lower bound on it. I can think of some problems I'd like to be solved that are mostly bound by us being too stupid to solve them.
On a day-to-day basis. I do maintain
I actually like one of the things that drives me crazy is like, oh, I like, when I meet AI people, it's like, oh, we need AGI so I can have household chore robot. I'm like, are you shitting me? That's all you can think of? Really?
here's something which I predict will happen. That's a prediction. I maintain
At the moment, Hyper,
that
it
as
was
AI
OpenAI though in 2019.
becomes more powerful, then people will change their behaviors. And we will see all kinds of unprecedented things which are not happening right now. And I'll give some examples. I do like I think for better or worse, the frontier companies will play a very important role in what happens, as will the
Yes,
government. And the kind of things that I think
unfortunately.
you'll see, which you see the beginnings of companies that are fierce competitors starting to collaborate on AI safety. You may have seen OpenAI and
Mm,
Anthropic doing a first small step, but that did not exist. That's actually something which I
financial
predicted in one of my
pressures.
talks about 3 years ago, that such a thing will happen. I also maintain that as AI continues to become more powerful, more visibly powerful, there will also be a desire from governments and the public to do something. And I think
That's
that this is
worst
a very
possible
important force
case. Mm,
of
do
showing
not
the
slow
AI.
down the engine of
That's number
progress.
one. Number two, okay, so then the AI is being built. What needs to be done? So one thing that I maintain that will happen is that right now, people who are working on AI, I maintain that the AI doesn't feel powerful because of its mistakes. I do think that at some point the AI will start to feel powerful, actually. And I think when that happens, we will see a big change in the way all AI companies approach safety. They'll become much more paranoid. I think I say this as a prediction that we will see happen. We'll see if I'm right. But I think this is something that will happen because they will see the AI becoming more powerful.
I don't know
Everything
about
that's
that,
happening
man.
right now, I maintain, is because people look at today's AI and it's hard to imagine the future AI.
Quite
And
easy to
there is a
imagine.
third thing which needs to
Me at
happen.
least.
And I think this is this and I'm talking about it in broader terms, not just from the perspective of SSI, because you asked me about our company. But the question is, okay, so then what should the companies aspire to build?
Yeah.
What should they aspire to build? And there has been one big idea that actually everyone has been locked into, which is the self-improving AI. And why did it happen? Because there is fewer ideas than companies. But I maintain that
Well,
there
it's
is
weird that it
something
doesn't work,
that's
right?
better to build.
Should.
And I think that everyone will actually want that. It's like the
Mm-hmm.
AI that's robustly aligned to care about sentient life specifically. I think in particular, there's a case to be made that it will be easier to build an AI that cares about sentient life than an AI that cares about human life alone, because the AI itself will be sentient. And if you think about things like mirror neurons and human empathy for animals, which is, you might argue it's not big enough, but it exists. I think
Anybody
it's an
know if
emerging
Ilya goes to
property from
Burning
the
Man?
fact that we model others with the same circuit that we use to model ourselves, because that's the most efficient thing to do.
So even if you
Nah,
got an
that's
AI to
sketch.
care about sentient beings, and it's not actually clear to me that that's what you should try
That's
to do with resolved
sketch.
alignment, it would still be the case that most sentient beings will be AIs. There will be trillions, eventually quadrillions of AIs. Humans will be a very small fraction of sentient beings. So
Fuck.
it's not clear to me if the goal is some kind of human control over this future civilization, that this is the best criterion.
It's true. I think that it's possible it's not the best criterion. I'll say two things. I think that thing number one, I think that I think that care for sentient life, I think there is merit to it. I think it should be considered. I think that it will be helpful if there was some kind of a short list of ideas that then the companies, when they are in this situation, could use. That's number two. Number three, I think it would be really materially helpful if the power of the most powerful superintelligence was somehow capped, because it would address a lot
No.
of these concerns.
No.
The question of how to do it, I'm not sure, but I think that would be materially helpful when you're talking about really, really powerful systems.
Yeah. Before we continue the alignment discussion, I want to double click on that. How much room is there at the top? How do you think about superintelligence? Do you think, I mean, using this learning efficiency idea, maybe is just extremely fast at learning new skills or new knowledge? And does it just have a bigger pool of strategies? Is there a single cohesive it in the center that's more powerful or bigger? And if so, do you do you imagine that this will be sort of godlike in comparison to the rest of human civilization, or does it just feel like another agent or another cluster of agents?
So this is an area where different people have different intuitions. I think it will be very powerful for sure. I think that what I think is most likely to happen is that there will be multiple such AIs being created roughly at the same time. I think that
Not if you slow down.
if the
The other guy's
cluster
not worried
is
about the
big enough,
safety.
like if the cluster is literally continent sized, that thing could be really powerful indeed, right? If you literally have a continent sized cluster, like those AIs can be very powerful. And I like
Probably don't
all I can
remotely
tell
need
you
that.
is that if you're talking about extremely powerful AIs, like truly dramatically powerful, then yeah, it would be nice if they could be restrained in some ways, or if there was some kind of an agreement
Good
or
luck.
something. Because I think that if you are saying, hey, like if you really like what is the concern of superintelligence? What is one way to explain the concern? If you imagine a system that is sufficiently powerful, like really sufficiently powerful, and you could say, okay, you need to do something sensible, like care for sentient life, let's say, in a very single-minded way, we might not like the results. That's really what it is. And so maybe, by the way, the answer is that you do not build an RL agent in the usual sense. And actually, I'll point several things out. I think human beings are a semi-RL agent, We pursue a reward, and then the emotions or whatever make us tire out of the reward. We pursue a different reward. The market is it's like a very short-sighted kind of agent. Evolution is the same. Evolution is very intelligent in some ways, but very dumb in other ways. The government has been designed to be a never-ending fight between three parts, which has an effect. So I think things like this.
That's the
Another
most
thing that makes
statement
this
of all
discussion
statements.
difficult is that we are talking about systems that don't exist, that we don't know how to build. Right? That's the other thing. And that's actually my belief. I think
I
what
have
people are
some
doing right
systems
now
that I do know how to
will
build
go
that
some
don't
distance
exist.
and then peter out. It will continue to improve, but it will also not be it. So the it, we don't know how to build. And I think that a lot hinges on understanding reliable generalization. And I'll say another thing, which is like, one of the things that you could say is what that cause alignment to be difficult is that human value, that it's your ability to learn human values is fragile. Then your ability to optimize them is fragile. You actually learn to optimize them? And then can't you say, are these not all instances of unreliable generalization? Why is it that human beings appear to generalize so much better? What if generalization was much better? What would happen in this case? What would be the effect? But those we can't, like, those questions are right now still unanswerable.
How does one think about what AI going well looks like? Because I think you've scoped out how AI might evolve. We'll have these sort of continual learning agents. AI will be very powerful. Maybe there will be many different AIs. How do you think about lots of continent compute size intelligences going around? How dangerous is that? How do we make that less dangerous? And how do we do that in a way that protects a equilibrium where there might be misaligned AIs out there and bad actors out there?
These safety people are like, before we even have solved the problem to have all the good that can come out of that, they're like coming up with hypothetical evils that may or may not even exist.
One reason why I liked the AI that cares for sentient life,
Hmm.
and we can debate on whether it's good or bad, but if the first N of these dramatic systems actually do care for, love humanity or something, care for sentient life, obviously this also needs to be achieved. This needs to be achieved. So if this is achieved by the first N of those systems, then I can see it go well.
I actually do think that's possible, Hyper, but like it's sci-fi shit, and it's like we're not going to build a continent-sized cluster ourselves, right?
At least for quite some time. And then there is the question of what happens in the long run.
Yeah.
What happens in the long run? How do you achieve a long run equilibrium? And I think that there is an answer as well. And I don't like this answer, but it needs to be considered. In the long run, you might say, okay, so if you have a world where powerful AIs exist, in the short run, you could say, okay, you have universal high income. You have universal high income. And we're all doing well. But we know that, what do the Buddhists say? Change is the only constant. And so things change. And there is some kind of government political structure thing, and it changes. Because these things have a shelf life. Some new government thing comes up and it functions, and then after some time, it stops functioning. That's something that we see happening all the time. And so I think that for the long run equilibrium, one approach, you could say, okay, so maybe every person will have an AI that will do their bidding. And that's good. And if that could be maintained indefinitely, that's true. But the downside with that is, okay, so then
Like
the AI goes and like earns money for the person, and advocates for their needs
that's
in
like
the
nothing
political
burger.
sphere, and maybe then writes a little report saying, okay, here's what I've done, here's the situation, and the person says, great, keep it up. But the person is no longer a participant, and then you can say that's a precarious place to be in. But so I'm going to preface by saying I don't like this solution, but it is a solution. And the solution is if people become part AI with some kind of Neuralink plus plus. Because what will happen as a result is that now the AI understands something and we understand it too. Like, because now the understanding is transmitted wholesale. So now if the AI is in some situation, now it's like you are involved in that situation yourself fully. And I think this is the answer to the equilibrium.
I wonder if the fact that emotions, which were developed millions, or in many cases billions of years ago in a totally different environment, are still guiding our actions so strongly,
I wonder
is an
why he's talking
example
about this
of
shit. It's
alignment
probably
success.
just like
To maybe spell out what I
he doesn't want to give
mean,
up much about what he's
the
actually doing.
brainstem has these, I don't know if it's more accurate to call it a value function or reward function, but the brainstem has a directive where it's saying mate with somebody who's more successful. The cortex is the part.
No, he did not literally say nothing the entire podcast, Ryan. Like Ilya is actually, I think in AI, he is probably the best speaker in AI. Like I remember, and he's still the same way. He speaks with such an an intentionality and a clarity. Oops. Uh, yeah, such an intentionality and a clarity. Yeah.
That
Hang on.
understands what does success mean in the modern context.
Finish
But
this.
the brainstem is able to align the cortex and say,
And fix
however
this.
you recognize success to be, and I'm not smart enough to understand what that is, you're still going to pursue this directive.
I think there is. So I think there's a more general point. I think it's actually really mysterious how the brain encodes high-level desires. Sorry, how evolution encodes high-level desires. Like it's pretty easy to understand how evolution would endow us with the desire for food that smells good, because smell is a chemical, and so just pursue that chemical. It's very easy to imagine such a evolution doing such a thing. But evolution also has endowed us with all these social desires. Like we really care about being seen positively by society. We care about being in a good standing. We like all these social intuitions that we have. I feel strongly that they're baked in. And I don't know how evolution did it because it's a high level concept that's represented in the brain. Like what people think, like let's say you are like, you care about some social thing. It's not like a low level signal like smell. It's not something that for which there's a sensor. Like the brain needs to do a lot of processing to piece together lots of bits of information to understand what's going on socially. And somehow evolution said that's what you should care about.
Yes.
I definitely take Ilya, Andre, Andrew, for sure.
How did it do it? And he did it quickly too.
Yeah.
Because I think all these sophisticated social things that we care about, I think they evolved pretty recently.
Yeah.
So evolution had an easy time hardcoding this high-level desire. And I maintain, or at least I'll say, I'm unaware of good hypothesis for how it's done. I had some ideas I was kicking around, but none of them.
But if you want to do all this social stuff, like this is the exact thing that you would build a big sim for. And like if you want to know how stuff emerges, right, without grounding stuff in human preconception, this is exactly the type of stuff you would do with my exact line of work with neural MMO and with all the other things, right?
None of them are satisfying.
Yeah. And what's especially impressive is if it was a desire that you learned in your lifetime, it kind of makes sense because your brain is intelligent. It makes sense why we'd be able to learn intelligent desires. But your point is that the desire is, maybe this is not your point, but one way to understand it is the desire is built into the genome, and the genome is not intelligent, right? But you're somehow able to describe this feature that requires, like, it's not even clear how you define that feature, and you can get it into you can build it into the genes.
Yeah, essentially. Or maybe I'll put it differently. If you think about the tools that are available to the genome, it says, okay, here's a recipe for building a brain. And you could say, here is a recipe for connecting the dopamine neurons to like the smell sensor.
Yeah.
And if the
Thinking
smell is
about
a certain
evolution's
kind of,
useful.
good smell, you want to eat that. I
I mean, he's no longer doing like pure LLM stuff, Ryan. Like it makes sense he's looking for other stuff. The safety thing I actually don't know, and I never really got full context on how he looks at this stuff from OpenAI. There's definitely some weird stuff there. I'd say of the big companies, like less weird than what the hell OpenAI and Anthropic are doing now. Still weird.
Imagine the genome doing that. I'm claiming that it is harder to imagine. It's harder to imagine the genome saying you should care about some complicated computation that your entire brain, that like a big chunk of your brain does. That's all I'm claiming. I can tell you like a speculation. I was wondering how it could be done. And let me offer a speculation and I'll explain why the speculation is probably false.
So, Plum, there's a difference between being a good speaker in the sense that, like, oh yeah, people like listening to you. If that's your goal, go be a politician and lie your ass off. And being a good technical speaker who is actually precise and intentional and correct more often than everyone else.
So the speculation is, okay, so the brain, it's like, the brain has those regions, you know, the brain regions. We have our cortex, right?
Yep.
It has all those brain regions. And the cortex is uniform, but the brain regions and the neurons in the cortex, they kind of speak to their neighbors mostly. And that explains why you get brain regions. Because if you want to do some kind of speech processing, all the neurons that do speech need to talk to each other. And because neurons can only speak to their nearby neighbors for the most part, it has to be a region. All the regions are mostly located in the same place from person to person. So maybe evolution hard-coded literally a location on the brain. So it says, oh, like when like, you know, the GPS of the brain, GPS
I can see
coordinates
why
such and
he'd be
such,
thinking
when that
about
fires,
this.
that's what you should care about. Like maybe that's what evolution did, because that would be within the toolkit of evolution.
Yeah, although there
Eccentric. Observe the bounty behind you.
are examples where, for example, people who are born blind have that area of their cortex adopted by another sense. And I have no idea, but I'd be surprised if the desires or the reward functions which require visual signal no longer worked. You know, people who have their different areas of their cortex co-opted. For example, if you no longer have vision, can you still feel the sense that I want people around me to like me and so forth? Which usually there's also visual cues for.
So I actually fully agree with that. I think there's an even stronger counter argument to this theory, which is like if you think about people, so there are people who get half of their brains removed in childhood.
Yeah.
And they still have all their brain regions, but they all somehow move to just one hemisphere, which suggests that the brain regions, their location is not fixed.
Yeah.
And so that theory is not true. It would have been cool if it was true, but it's not. And so I think that's a mystery, but it's an interesting mystery. Like the fact is, somehow evolution was able to endow us to care about social stuff very, very reliably. And even people who have like all kinds of strange mental conditions and deficiencies and emotional problems tend to care about this also.
AI tools like deepfakes, voice clones, and agents have dramatically
Ilya's
increased
actually
the
thinking about
sophistication of
out
fraud
there
and
stuff.
abuse. So it's more important than ever to actually understand the identity and intent of whoever or whatever is using your platform. That's exactly what Sardine helps you do. Sardine brings together thousands of device, behavior, and identity signals to help you assess risk. Everything from how a user types or moves their mouse or holds their device, to whether they're hiding their true location behind a VPN, to whether they're injecting a fake camera feed during KYC selfie checks. Sardine combines these signals with insights from their network of almost 4 billion devices. Things like a user's history of fraud or their associations with other high-risk accounts, so you can spot bad actors before they do damage. This would literally be impossible if you only use data from your own application. Sardine doesn't stop at detection. They offer a suite of agents to streamline onboarding checks and automate investigations. So as fraudsters use AI to scale their attacks, you can use AI to scale your defenses. Go to sardine.ai/Thwarkesh to learn more and download their guide on AI fraud detection. What is SSI planning on doing differently? So presumably your plan is
All right,
to be one
enough
of
of
the
whatever
frontier
the fuck
companies
this is in
when
the
this time
comments.
arrives. And then what is presumably you started SSI because you're like, I think I have a way of approaching how to do this safely in a way that the other companies don't. What is that difference?
So the way I would describe it as there are some ideas that I think are promising, and I want to investigate them and see if they are indeed promising or not. It's really that simple. It's an attempt. I think that if the ideas turn out to be correct, these ideas that we discussed around understanding generalization,
Hmm.
if these ideas turn out
So,
to be correct,
I mean, the one good thing about this is I would think that with all the stuff that he's thinking about, hopefully we're not just going to get like some slight variation of a language model out of SSI. It seems like he has genuinely like raised a bunch of money to go just back to the drawing board and think about stuff fully, and that's pretty awesome.
then I think we will have something worthy. Will they turn out to be correct? We are doing research. We are squarely age of research company.
Yeah.
We are making progress. We've actually made quite good progress over the past year, but we need to keep making more progress.
Does it mean he might try out his ideas? Dude, do you know how many people will raise? Like, usually the opposite happens. You raise $3 billion and you're completely locked to a trajectory where, like, it's obligation to investor this quarter, that quarter, next. Like, look, that happens even way before $3 billion. Companies go raise $100 or $200 million, and it's like, you know, you're completely beholden with no freedom to do anything interesting whatsoever.
More research. And that's how I see it. I see it as an attempt
Yeah, I'd say
to
so,
be
Ryan.
an attempt to be a voice and a participant.
People have asked, your co-founder and previous CEO left to go to Meta recently, and people have asked, well, if there was a lot of breakthroughs being made, that seems like a thing that should have been unlikely. I wonder how you respond.
Yeah, so for this,
Kind
I
of a
will
dipshit
simply
question.
remind a few facts that may have been forgotten. And I think these facts, which provide the context, I think they explain the situation. So the context was that we were fundraising at
No
a
raising.
32 billion valuation, and then Meta came in and offered to acquire us, and I said no. But my former co-founder, like in some sense, said yes. And as a result, he also was able to enjoy from a lot of near-term liquidity. And he was the only person from
Cashed out.
SSI to join Meta.
It sounds like SSI's plan is to be a company that is at the frontier when you get to this very important period in human history.
I mean, I guess I don't know his co-founder, like, what he had originally. People have different motivations, right? Like, and like Ilya, presumably, like, Ilya has enough personally that there's basically nothing you can offer him that's going to be more interesting to him than what he's doing now, right? Like, money doesn't buy, like, money only buys so much.
Where you have superhuman intelligence and you have these ideas about how to make superhuman intelligence go well. But other companies will be trying their own ideas. What distinguishes SSI's approach to making superintelligence go well?
The main thing that distinguishes SSI is its technical approach. So we have a different technical approach that I think
Dude, I don't know anything about Mira or like her technical background whatsoever, but I know Ilya's research, right? I have no idea on what basis Mira was in the position she's in. Maybe she does have good research. I don't know anything about her though. I know about Ilya. I've seen Greg and his engineering in action. Mira wasn't even there when I was there. I know Altman, and I know that I don't trust him. What else the fuck? Who else? Oh, I know Radford is awesome. I know Schulman is very narrowly the algorithms guy, but he's the best algorithms guy.
is worthy. And we are pursuing it. I maintain that
Yeah, there's a little bit more to that one though,
in
Ryan.
the end, there will be a convergence of strategies. So I think there will be a convergence of strategies where at some point, as AI becomes more powerful, it's going to become more or less clearer to everyone what the strategy should be. And it should be something like, yeah, you need to find some way to talk to each other, and you want your first actual, like real super intelligent AI to be aligned and somehow be, you know, care for sentient life, care for people, democratic, one of those, some combination of thereof. And I think this is the condition that everyone should strive for. And that's what SSI is striving for. And I think that this time, if not already, all the other companies will realize that they're striving towards the same thing. And we'll see. I think that the world will truly change as AI becomes more powerful.
Yeah.
And I think
This is like so counting your chickens before they hatch, though, right? All these like, oh, what's AGI gonna look like? Motherfucker figured out how to build it, right? I take Ilya's take over Dario's or Sam's, or by far.
a lot of these forecasts will, like, I think things will be really different and people will be acting really differently.
What speaking of forecasts, what are your forecasts to this system you're describing, which can learn as well as a human, and subsequently, as a result, becomes superhuman?
I think like 5 to 20.
5 to 20 years.
Mhm.
So I just want to unroll how you might see the world coming. It's like we have a couple more years where these other companies are continuing the current approach, and it stalls out. And stalls out here meaning they earn no more than low hundreds of billions in revenue, or how do you think about what stalling out means?
Yeah. I think I think it could stall out, and
Make a lot of money.
I think stalling out will look like it will all look very similar
Yeah.
among all the different companies, something like this. I'm not sure because I think even with stalling out, I think these companies could make a stupendous revenue.
Yeah.
Maybe not profits because they will they will need to work hard to
Yeah.
differentiate each other from themselves, but revenue definitely.
Yeah.
But there's something in your model implies that
Yeah, dude, I was just an intern when I was an undergrad. I was there for 6 months before I did my PhD.
when the correct
But I was there at a good time, right? Like, that was, in my eyes, the golden age of OpenAI. Like, Dota in particular is the coolest damn thing I've ever seen.
solution does emerge, there will be convergence between all the companies. And I'm curious why you think that's the case.
Well, I was talking more about convergence on their larger strategies.
Hmm.
I think eventual convergence on the technical approach is probably going to happen as well. But I was alluding to convergence to the larger strategies.
Right.
So what exactly is the thing that should be done?
I just want to better understand how you see the future unrolling. So currently we
Kinda
have these
has to
different
be with the
companies, and
swamp
you
people
expect their approach
constantly.
to continue generating revenue,
Yes.
but not get to this human-like learner.
Yes.
So now we have these different forks of companies. We have you, we have thinking machines, there's a bunch of other labs.
Yes.
And maybe one of them figures out the correct approach.
Mm-hmm.
But
Puffer's
then
profitable.
the release of their product makes it clear to other people how
Way
to do
smaller.
this thing.
Profitable.
I think it won't be clear how to do it thing, but it will be clear that something different is possible,
Right.
and that is information. And I think people will then be trying to figure out how that works. I do think though that one of the things that I think not addressed here, not discussed, is that with each increase in the AI's capabilities, I think there will be some kind of changes, but I don't know exactly which ones in how things are being done. And so, like, I think it's going to be important, yet I can't spell out what that is exactly.
And how are the by default you would expect the company that has the model company that has that model to be getting all these gains because they have the model that is learning how to do all has the skills and knowledge that it's building up in the world. What is the reason to think that the benefits of that would be widely distributed and not
Have the
just end up at
stats.
whatever model company gets this continuous learning loop going first?
What?
I think that empirically what happens. So here is what I think is going to happen. Number one, I think empirically, when let's look at how things have gone so far with the AIs of the past. So one company produced an advance, and the other company scrambled and produced some similar things after some amount of time, and they started to compete in the market and push push the prices down. And so I think from the market perspective, I think something similar will happen there as well. Even if someone, it's okay, we are talking about the good world, by the way, where what's the good world? what's the good world? Where we have these powerful human-like learners that are also like, and by the way, maybe there's another thing we haven't discussed on the spec of the super intelligent AI that I think is worth
Haven't tried
considering,
TPUs eccentric.
is that you make it narrow. Can be useful and narrow at the same time. So you can have lots of narrow super intelligent AIs. But suppose you have many of them, and you have some company that's producing a lot of profits from it, and then you have another company that comes in and starts to compete, and the way the competition is going to work is through specialization. I think what's going to happen is that
Fine.
the way competition loves specialization. And you see it in the market, you see it in evolution as well. So you're going to have lots of different niches, and you're going to have lots of different companies who are occupying different niches in this kind of world. Where you might say, yeah, like one AI company is really quite a bit better at some area of really complicated economic activity, and a different company is better at another area, and the third company is really good at litigation, and
But
that's the one you want
is
to go
this
there.
contradicted by what human-like learning implies? Is that like it can
Oh.
learn?
It can, but you have accumulated learning. You have a big investment. You spent a lot of compute to become really, really, really good, really phenomenal at this thing. And someone else spent a huge amount of compute and a huge amount of experience to get really, really good at some other thing.
Right.
You apply a lot of human learning to get there, but now like you are at this high point where someone else would say, look, like I don't want to start learning what you've learned to
I
go
guess
through this.
that would require many different companies to begin at the human-like continual learning agent at the same time, so that they can start their different research in different branches. But if one company, gets that agent first or gets that learner first, it does then seem like, well,
Companies are all within a few
like
years
if
of
you just
each
think about
other.
every single job in the economy, you just have instance learning each one seems tractable for a company.
Yeah, that's a valid argument. My strong
You still have
intuition
to
is that
get
it's
the
not how
damn
it's going to
data.
go.
I think I'd
My
go with
strong
Ilya on
intuition is
this
that, yeah,
one.
like the argument says it will go this way.
Yeah.
But my strong intuition is that it will not go this way. That this is in theory, there is no difference between theory and practice. In practice, there is. And I think
Yeah.
that's going to be one of those.
A lot of people's models of recursive self-improvement literally explicitly state we will have 1,000,000 Ilyas in a server that are coming in with different ideas, and this will lead to a superintelligence emerging very fast. Do you have some intuition about how parallelizable the thing you are doing is? What are the gains from making copies of Ilya?
I don't know. I
Tremendous.
think
You get a
I
million
think there'll
Ilyas, like
definitely
all
be
the problems in the
there'll
world
be
are solved,
diminishing
dude.
returns because you want people who think differently rather than the same. I think that if they were literal copies of me, I'm not sure how much more
Dude, that's
incremental
so
value you'd get.
humble.
that-
That is so humble, dude. Give me give me 100 of me, and one, be the biggest damn ego check in the world, and two, I'd have a lot of cool shit done.
But people who think differently, that's what you want.
Why is it that it's been, if you look at different models, even released by totally different companies, trained on potentially non-overlapping data sets, it's actually crazy how similar LLMs are to each other.
Maybe the datasets are not as non-overlapping as it seems.
But there's some sense that it's like even if
That's
an individual
funny.
human might be less productive than the future AI, maybe there's something to the fact that human teams have more diversity than teams of AIs might have. But
Human
how
teams
do
are
we elicit
generally a
meaningful
mess.
diversity among AI? So I think just raising the temperature just results in gibberish. I think you want something more like different scientists have different prejudices or different
Yeah.
ideas. How do you
So-
get that kind of diversity among AI agents?
So the reason there has been no diversity, I believe, is because of pre-training.
Yeah.
All the pre-trained models are the same,
Same data.
pretty much, because they're pre-trained on the same data. Now, RL and post-training is where some differentiation starts to emerge because different people come up with different RL training.
Yeah.
Yeah.
And then I've heard you hint in the past about self-play as a way to either get data or match agents to other agents with equivalent intelligence to kick off learning.
Ooh.
How should we think about why there's no public proposals of this kind of thinking working with LLMs?
I would say there
Kind
are
of tough to
two things to
formulate.
say. I would say that
No
the
guy that
reason
did
why I
that.
thought self-play was interesting is because it offered a way to create models using compute only without data, right? And if you think that
Yes,
data is the ultimate bottleneck, then using compute only is very interesting. So that's what makes it interesting. Now, the thing is that self-play, at least the way it was done in the past, when you have agents which somehow compete with each other, it's only good for developing a certain set of skills. It is too narrow. It's only
Oh, Ilya. Ye of little faith. OpenAI got out of Dota too early, man. They got out of Dota too early. They barely scratched the surface. Now, this is one of the major things you're gonna see in the next couple of years.
good for like negotiation, conflict, certain social skills, strategizing, that kind of stuff. And so if you care about those skills, then self-play will be useful. Now, actually, I think that self-play did find a home, but just in a different form. So things like debate, prove a verifier, you have some kind of an LLM as a judge, which is
Yeah,
also
that's fair.
incentivized to find mistakes in your work. You could say
Fair.
this is not exactly self-play,
Not
but
quite the
this
same
is,
though.
a related adversarial setup that people are doing, I believe.
Hmm.
And really, self-play is an example of is a special case of more general competition between agents, right? The natural response to competition is to try to be different. And so if you were to put
Ooh.
multiple agents,
I had a piece of work on Neural MMO 1 that showed this while I was at OpenAI. It was really cool. Like you literally would just let the agents go and they'd all go in different directions and like different models would learn to go in different directions so that they would like specialize differently and not compete.
and you tell them, you all need to work on some problem, and you're an agent, and you're inspecting what everyone else is working, you're going to say, well, if they're already taking this approach, it's not clear I should pursue it. I should pursue something differentiated. And so I think that something like this could also create an incentive for a diversity of approaches.
Yeah. Final question. What is research taste? You're obviously the person in the world who is considered to have the best taste in doing research in AI. You were the co-author on many of the biggest things that have happened in the history of deep learning, from AlexNet to GPT-3 to so on. What is it that? How do you characterize how you come up with these ideas?
I can answer, so I can comment on this for myself. I think different people do it differently. But one thing that guides me personally is an aesthetic of how AI should be by thinking about how people are, but thinking correctly. Like, it's very easy to think about how people are incorrectly. But what does it
Huh. Huh.
mean to think about people correctly?
Yeah.
So I'll give you some examples. The idea of the artificial neuron is directly inspired by the brain. And it's a great idea. Why? Because you say, sure, the brain has all these different organs, it has the folds, but the folds probably don't matter. Why do we think that the neurons matter? Because there's many of them. It kind of feels right, so you want the neuron.
Yeah.
You want some kind of local learning rule that will change the connections. You want some local learning rule that will change the connections between the neurons. Right? It feels plausible that the brain does it. The idea of the distributed representation. The idea that the brain responds to experience. Our neural net should learn from experience, not response. The brain learns from experience. The neural net should learn from experience. And you kind of ask yourself, is something fundamental or not fundamental? How things should be.
Yeah.
And I think that's been guiding me a fair bit, kind of thinking from multiple angles and looking for almost beauty, simplicity. Ugliness, there's no room for ugliness. It's just beauty, simplicity, elegance, correct
Mm.
inspiration from the brain. And all of those things need to be present at the same time. And the more they are present, the more confident you can be in a top-down belief. And then the top-down belief is the thing that sustains you when the experiments contradict you.
Hmm.
Because if you just trust the data all the time, well, sometimes you can be doing a correct thing, but there's a bug. But you don't know that there is a bug. How can you tell that there is a bug? How do you know if you should keep debugging or you conclude it's the wrong direction? Well, it's the top down. Well, how should
Man, this is true to an extent that is really difficult to convey to people who have not sunk basically their entire life into research. The amount of mental resilience that research requires, the amount of distractors, the amount of it's so easy to go with the flow of what everyone is doing, but to actually do something that is new and out there, um, it requires such an incredibly strong conviction on the path that you've taken that it's like borderline madness. But then, of course, the difference between it being truly mad and simply dedication that is required, that you can explain exactly what you're doing, and nobody can really come up with any meaningful arguments against it. It seems like people mostly agree but don't want to put in the work that you do. Probably on the right path.
you can say the things have to be this way.
Right.
Something like this has to work. Therefore, we got to keep going. That's the top down. And it's based on this like multifaceted beauty and inspiration by the brain.
All right. We'll leave it there.
I'm fixing that with Puffer, Ryan.
Thank you so
Ilya,
much.
thank you so much.
Woo. All right. Appreciate it.
That was great.
Yeah, I enjoyed it.
Yeah, me too. Hey, everybody. I hope you enjoyed that episode. If you did, the most helpful thing you can do is just share it with other people who you think might enjoy it. It's also
Everybody
helpful
watching,
if
there you go.
Leave a rating or a comment on whatever platform you're listening on. If you're interested in sponsoring the podcast, you can reach out at dwarkesh.com/advertise. Otherwise, I'll see you on the next one.
Cool. So, for everybody watching, hello. At least some of you are new around here. So, hi, I'm Joseph. I am a reinforcement learning researcher. Finished my PhD a couple years ago. Now I run Puffer, which is a small private RL lab. We do all open source stuff. We train tiny superhuman models in seconds. You can run them on your laptop. It's all right here, and I stream pretty much all of my dev on the project as well. So if any of this sounds interesting to you and you'd like to see more of this stuff, first of all, start the Puffer on GitHub. Helps me out a ton. Try out the code. We have all docs and demos here. You can join the Discord to get involved with development. Pretty much everybody involved professionally with this stuff just started by building some environments, starting to get a feel for the field like this. And you can also follow me on X, which is the main spot that I post all of my stuff. I am currently working on Puffer 4, which is targeting 10 million step per second RL training. We're going to have something that can really train on tens of thousands of years worth of data on a single server. We have a new architecture that we've come up with Puffer 4. We are doing some low-level dev on optimized kernels, a lot of just transparency on how to make this stuff actually as fast as it needs to be. And that's pretty much what I do in a nutshell. We hit like 40 concurrent pretty much across platforms here. So, funny that that's how it goes as soon as I pull up a VOD. But yeah, I'm going to go get some dinner. I'll answer any quick questions if anybody has them. Yeah, that is pretty much what I do. Oh yeah, and then the other thing is, if you're looking to get into RL or learn more, I do have a little bit of free educational material here. These 2 articles are the best place to start. This is all of my best advice for general engineering and how to view science in a way that will help you understand a lot more of what is out there quickly. And then this is the same for reinforcement learning. This is a pretty much step-by-step, like, read this, build this, read this, build this, and if you follow this, you will learn RL. Way less math heavy than a lot of the stuff out there. Kind of a pretty heavy blend of engineering with some basic science thrown in, a little bit of math. That's what I do. Hey, Hyper. You're doing podcast review? Good thing. Fireball. Yeah, the Fireball one is kind of like a funny thing. I am sort of serious about it in some sense that, like, I basically just said, hey, you know, all you guys are spending so much bloody time, like, arguing over the definitions of AGI and moving the goalposts every so often. You know, in 2018 or whatever, I just said, screw it. You know, the definition of AGI is when I can cast Fireball. So when AI produces something that's essentially magic, then we're good. Because otherwise, as you've seen, like, the name of the game is just move the damn goalposts around and, like, say a bunch of things that don't make any sense and don't really matter. So this was kind of just like, screw it, get back to real work, you know, build the awesome stuff, stop debating whether you've succeeded or not. Heh. Again, a funny one. Back in streams for more. NearNet, 0 to Hero. That's good. XAI claims about doing real-time video processing plus action model for Grok 5. If they try to do League just by, like, running Grok on League, it's going to be hilariously bad. If they actually spend a ton of compute to train like that on League, they might get something more sample efficient than Dota. They're going to spend a ton of money, though, for what is ultimately a worse result than OpenAI 5. Learning from scratch is good. Oh yeah. So this is, I actually have right behind me, here, I'll show this. So right behind me, you see I have the servers above me right here. And then if I turn this, you can see that monitor, I just got that. That actually has all of the experiment data for some of the 4.0 experiments. And honestly, the main thing with the new update for Puffer, we're trying to make RL about 3 times faster than the previous version. We have a new architecture that's going to be slightly better. And then we're going to use all this new speed to just run a massive, massive number of experiments. And there's a new visualizer for aggregating all that data to hopefully get us some really cool insights about RL. That's the main thing. I will say for Dorkesh, like, it's not bad, right? He kind of just strikes me as like a kind of a normal dude that doesn't have like a deep math and science background trying to understand this stuff and like talk about it generally, right? I think it was mostly the thing I said before, right? Where it's like, yeah, maybe it's just he has a big general audience and like some of his viewers are just like, oh, this guy's the AI genius, not like, it's kind of like Lex Friedman or Joe Rogan or what, like, you know how just there are these big podcasters that mostly they're just like dudes with a big audience and they talk to, like, they get a bunch of cool guests, but then for whatever reason some fraction of their viewers seem to mistake and think like, oh, actually the interviewer is the one who's a massive genius and like what they say is the word of God. Like, it seems fine. Micron exiting the consumer. I don't know anything about that. How would you train self-driving problem? Our biggest collab right now with the university. This Puffer Drive sim. This is being used by actual self-driving companies. Just a high-performance sim. You load in real map data to this thing. The point of this is that you can just like, you get so much data out of this that like, if you don't have a ton of real world data, but you have these maps, you can still train on a ton of scenarios. RL on the fly without catastrophic forgetting. Not really so I kind of have a different perspective, Fred. I'm not trying to hit the same target that everybody else is with LLM RL. What I'm trying to do is, instead of like, how do we make RL adapt? I'm just gonna make RL stupidly fast, and then make it very easy to have high performance simulators for tasks that you care about. You can just go train on petabytes or more of data for your given problem on one server and see every possible permutation of it. So, like, in some sense, I don't have to solve that problem for my approach to work. The big general models kind of have to solve that problem because they can't train on the amount of data that I do. It's kind of funny, like, the main objection I get to a lot of my work with this is, oh, well, it's good for games, but not much else. And then it's like, I take the exact same code, exact same everything. Like, ah, cool, it flies a drone. Ah, cool, it drives a car. And then I throw it on problems for clients. Like, the main thing Puffer does professionally is we build high performance sims for companies. And look, it does compute market pricing. Look, it does this finance task, right? So yeah, RL's really powerful. And it's gotten like 1,000x better in the last 2 years, and that's not hype, that's not exaggeration. It's actually gotten 1,000x better. And we've got at least another order of magnitude, probably 2, coming in the next couple of years. Jensen on Joe Rogan, that's hilarious. What do you do about pedestrians? Yeah, so you would want them in the sim, obviously. Like, it's not like we're insta deploying this. Like, this is a relatively small sim for some relatively smaller companies. There is a pedestrian model, I believe. Some maps have them. There's like a different pedestrian model, but yeah, you would want pedestrians. And then you can have them like cross randomly and have all sorts of different events and not collide with them. Initially, though, what this thing is really good for is like this thing gets you can basically train models that never collide or collide ridiculously infrequently. Frankly, there are bigger maps as well that have much longer horizon tasks in them. I think they're working on. The team for that is at NYU, and a couple of them are at NeurIPS right now, if anybody's there. But yeah, this is evidently, even in the current state, is already useful for driving sim companies. Not driving sim companies, for self-driving companies. So, cool. The plan for the next couple of days, I'm probably going to see if I can fix the vectorization stuff on stream tomorrow. We've got this new multi-threaded C backend for Puffer. And I need to redesign this chunk of code a little bit, and this should get us tens of millions of steps per second vectorization to support the new version. And then what other stuff is there? We've got custom kernel dev stuff to work on. We've got some experiments and a variety of different things for 4.0. But yeah, if you're new, start Puffer, join Discord, follow on X. Those things help. This is currently the fastest growing RL library, and I'd love to keep it that way. It really does help me just spend all my time on this project rather than doing other stuff, bullshit advertising. If you are interested in RL in a professional setting, we have stuff available for that. And that's about it. So, thank you. And I'm going to go get